Hello people, I'm going to start very soon. I just wanted to take a little screenshot and stuff. Let's go there. Let's maybe have this. Okay. That's going to be a nice screenshot for YouTube. Okay. Maybe not. It's not going to be a nice screenshot, but yeah, should be alright. Okay. So then we have this. We have everything ready. Oh, even the muting button. The mute button. Okay, so let me share the screen. Did I forget anything? No. Perfect. Wait, this is a bit loud. But hey! Oh, wait, I forgot my... This... And... Here we go. Okay. Hello people, it's me. And the music is a bit loud, so I'm just gonna reduce the sound a bit. And we'll be ready, maybe? Let's hope this is good enough. Okay, so yeah, last time we did actually a lot. We managed to... Well, now we can put blocks on the ground, right? We can place them. We can also... Well, we can destroy them still. We have also some generation, some very basic generation. World generation based on noise. So I can dig down. I have some... How else you could say? I have this. And I have the bedrock. Okay, then I also have... What do I have? I mean, I guess that's kind of all, actually. I was actually doing something last time we... Wait. Right. On the last stream. Let's go to tomorrow. Okay. So basically last stream I was trying to... I was trying to make a database for my blocks because I was using integers and it was like becoming a pain, right? And the thing is, let me actually make a document for that. Yeah, let's just make a document. So you have all of this, right? Tech tricks, you could say. So, okay, we have all of this. Let's do how voxels are stored, like voxels themselves. And basically we have, in a lot of games, well, a voxel can be stored as, well, as a type of a voxel. How voxel types are stored. The type of a voxel can be stored as an int. However, it then becomes hard to remember what this corresponds to. You can also use an enum, but that means we can't add new voxel types dynamically. Remember me. Remember me. Wait. Really? What do you mean by that? But hello! Hello! How are you? So we can also use an enum, but we can't add new types dynamically. It used to be cool. Explain my drawing. Oh! Yeah, explain my drawings. Yeah, I know you. EMD, right, on each. You made like you drew something for my game, so I remember. I mean, even if you didn't, I would have remembered you. This one, right? I remember distinctively because there was like a sprite that was named EDM, and I think I had like a lot of bugs due to that. I was very busy these past years. Okay, I see. I hope everything is a bit better now. Are you working on something interesting? Are you doing like anything fun? And we need a dependency every time. This we can use string name, but it's 8 bytes. So nope. So nope. But it's 8 bytes when we only need 4. Really? Realistically? So basically what I can do is... Well, can do. Is basically what I did is instead there are indices in a database of types. Yeah, and Balatro plus math game and a fun little multiplayer tag game. Oh, nice, nice, nice. Are you using Godot? I actually want to do some multiplayer, but I've never used, like I never did multiplayer on Godot. I know like the basics, right? Since I work in engines and stuff. And, well, yeah. But not on Godot. So like, are there replicated variables, RPCs? Do you have to use TCP, UDP? Like, I'm not sure about the how high level it is. I mean, Unreal has, Unreal has some default templates with like default types. Like it has a big architecture already there with like characters, bounds, controllers, player states, game mode, that kind of stuff, right? So it has like a whole networking architecture that Unity doesn't have, but that I really like. And when I go on new engines, I usually, like if I want to make a game, I usually make some kind of very similar architecture because I know it kind of works. And well, Unreal has basically for the player character, for example, some basic interpolation. Well, the interpolation is working with the network, like it has some prediction already coded in the engine. So that's kind of neat. But I don't think, well, Unity doesn't have that because it doesn't have any architecture by default. And I think Godot doesn't. I still use Godot, by the way. I do have a prototype of the math game if you want to try it. It's math game. I'm actually a bit interested. I love math, so maybe if it was something else, I would have told you. Maybe not now. I'm gonna work on my game. Maybe another time. That kind of stuff. But I'm actually kind of interested. Go for it. Yeah, and it is really nice for those big projects. Unity is a middle ground, but the main problem is backstabbing me. Yeah, and Godot is for fun, little stuff. Yeah, I mean, oh, did I show you? I mean, you haven't been here for a while, right? So basically, like 3 weeks ago, maybe, I started this project with basically I'm making my own Minecraft, but instead of like a plane, infinite plane, right now it's a donut. Right now. And just tell me when you want to try it. Well, just send the link in the chat if you want. And yeah, basically I can destroy cubes, right? I can put new cubes. And there's something actually crazy about it. As you can see, I can just rotate around, which is kind of neat. I have some basic generation. And let me show you. I really want to show it every time, every single time. Because I'm gonna show the context first. So basically, if you have cubes on a donut, Ad break hand. Oh, there's an ad break. Can you see it? Can you see the stream? Let me think. Yeah. Anyways, so yeah, the base problem with the donut is that since every cube is on top of another cube, it becomes smaller and smaller, and it turns into, well, when you dig, it turns into rectangles. So it sucks. So I just fixed that, and now it's cubes. And yeah, I was saying that last time I was making a database. I actually finished it. I modified things a little bit. I added those operators, so that way I don't need functions there anymore, and I can just access the data from the voxel type directly from the proxy. So this is kind of neat. It's like a pointer, basically. It's acting like a pointer. Implementation is simple. Then I quickly added this to parse my data. I have the texture index there. So then I have my voxels. I'm basically loading this from the file there. And in here I have like the data of my cubes. I have my textures. And yeah, it's just taking the right texture, right? So everything is good. I mean, ideally I should maybe put like assign a string name to my textures, so it, you know, so I don't have to put like random indices, but it's like independent enough right now. And basically in my code, for example, in the generator, I can just do something like this. So I'm getting the proxies ahead of time for kind of optimization to like prevent the ifs and stuff. Let's go there. Let's go inside. So yeah, I have a static variable. I'm not sure if this is actually worth it. I would say maybe it is. I'm actually not sure. Well, let's say it is. So yeah, I have those, I can get those, and then since I have like a big loop, I just reuse those variables directly, so it's like an integer, so it's like as fast as before, almost, probably. And here we go. I can just assign a string name lookup. I mean, this is done. Did I push actually? I kind of have to push. Because it's working well. Yeah, I definitely have to push things. Oh, database. Yep. So everything by default. And now I'm just gonna reset suffix cube. I'm gonna reset. What am I gonna reset? So Excel database is good. Chunk loader. I'm not sure about chunk loader. Oh yeah, not chunk loader is not used actually. So yeah, chunk loader, reset. And I think it should be good. So voxel database added. You don't use GDScript? I do, but for scripting. Let me explain this like just a bit later. I just want to push this first, get it done with. Git add this. Did I modify the Torus? Oh right, I did. Okay, that was there. Okay, so I'm just gonna go here, boom, and I do that. And I should also have access to this database from GDScript, but instead of like an integer and that kind of stuff, it's just gonna be a string name. And yeah, the reason, basically I use just a bit of GDScript, but the reason, well, the thing is, I'm probably going to use it a lot more for gameplay, but I'm making a big distinction between gameplay features and engine features. and engine features are going to be in the engine, and gameplay features might, be are going to be in GDScript, with a few exceptions, like some components, like maybe AI algorithms that are more engine, right? So, you can argue this is like for optimization. You can argue that this is, I don't know, something else. Have you slept? You're still streaming? Yeah, I slept. I just started streaming again. I just started the stream. And yeah, basically the reason is really architecture-wise. It's really to split the engine from the gameplay. Yeah. That's good. Yeah. So, like, for example, well, the raycast and all of that is in the engine. But if you look at the player, you have like the whole movement and stuff. And when you try to hit a block, like to destroy a block, I'm doing that in the script, right? In GDScript. Oh, that's good. Yeah. What's your big idea for making the game go from a normal Minecraft clone to something better? I mean, I have a lot of ideas. I mean, my first one is obviously the geometry, which is going to be impossible geometry, basically. Like, a donut, but when you dig down, it's like still cubes, right? Oh, wait, I can destroy the bedrock. But yeah, basically it's still a cube, but like since each block is on top of another cube, then, it's not supposed to be, it's supposed to be getting smaller and smaller. So that kind of stuff, like maybe infinite death in that donut, non-Euclidean geometry, I wanna try that. But I guess like it's a lot of space things, you could say. But then like more gameplay-wise, I want the player to build his own weapons. I want the player to build like vehicles, to go in space, that kind of stuff. I want entities to be voxels too, so we can like cut an arm or something, right? Like have maybe weaknesses, like for some bosses. I want a giant turtle, for example, on which you can build your own city, like in Drawn to Life. Yeah, that's like, I love Drawn to Life. And in Drawn to Life, you basically have this kind of turtle that, well, you just have a village on it, right? So I'm just thinking about like some kind of giant entity, you could say. Maybe not monster, but yeah, entity that works on the planet. But you can get on that entity and you can just build your own stuff. And basically have some kind of giants. I want some giants in my game. That's really cool. Is this your dream game? Or is a game to practice for your dream game? That's probably... You could say it's my dream game. I haven't thought about it, but it's basically like one Sunday I just started doing that because I just wanted to make voxels after working on some demo for my previous game. And... Well, I just went to it for passion. I'm just very passionate about math, and I wanted to try a few things out. And I'm basically making this project a lot for myself, because I want to do math. So it depends what you mean by dream game, but to me it's just what I want to do. I just want to, because I guess a lot of people, and me myself, like my previous games, when you make a game, you want the final product, right? You want the game to be successful. You want, the game to be played. You want to win a game jam, maybe. You want to, that kind of stuff. In my case, maybe money. Maybe you want money. In my case, after my previous game, my previous project, I was like, okay, fuck it. Fuck it. I'm just gonna... Let's not think about anything. Let's just do what I want to do. And I just made some voxels. And then I wanted some distorted geometry, so I did that. Then I wanted the game to, I wanted things to look like cubes when in the cave, so I did that. And I'm basically just doing what I'm doing. So, when people talk about a dream game, I feel like it's because they have a very concrete idea of what they want, and they really want to realize that idea. And it's not really the case for me. I just want to do math, really. I just want to do like some crazy geometry. So, the process is the reward. So in this case, it's not a dream because it's already there, right? A dream game is a game that you dream to have, but it's not a game that I dream to have. It's a game that I just wanna make. So that's it. What was that? Oh, I found a bug. Oh, okay, I get it. Hey, it's because there's a delay with the pickup. I really like the concept, though in my humble opinion, I think the cubes should be bigger. I don't know, I like big, gigantic stuff, And W6 song music, thank you. It's actually, well, actually, it is Silksong, indeed. I thought it was Hollow Knight. Well, I mean, yeah. Okay. So yeah, that's basically a bug. Okay. Let me just put it in to do in the end. Bugs when spam clicking clicks blocks are added at the wrong place, basically. And I was actually thinking about making the cube smaller. You think the cube? By the cube, what do you mean? Because basically everything is relative, right? Like if I'm on the ground like this, everything looks like really big, right? But yeah, if I'm like there, it looks like really small. Right now the player doesn't have like a specific size. And I was thinking of having a lot of details for like the surface. So my priority is actually to load chunks lazily. Because right now I'm loading everything at the same time. So let's do that. So I have the chunk. I have the generator. The generator is working well. We can generate. Actually, skip chunk generator. And what else? And yeah, I want to generate chunks so I can make my donut a lot bigger. And I want to test performance with that. So I can then add more details, potentially, and that kind of stuff. So, Steve, okay. Let me think. I wanna add... What do I wanna add? I don't know. Yeah. Visuals. So I had... Okay, the chunk loader, actually. I want to do the chunk loader. So basically I have a class that is going to load the chunks around. And I need a way to generate chunks around the player. So I'll be going in the collider, in the collision system phase. Because I have like a few things, right? So it's actually a bit tricky. It's actually a lot, well, really complicated. I guess I just need a list of observers. Yeah, space observers. It's actually in core, probably. So this is good. I know it's bad for me, but I like to make the concept. Then right away make the juice/game feel right away, which is what I did for my math game and multiplayer game. I know it's wrong to do it early, but juice is my specialty nowadays. I think juice is really important. And sometimes you don't know if the game is going to be good without the juice. So I think it kind of depends. Maybe for some kind of Minecraft game, it's a bit different because I guess the mechanics are maybe more important than the juice. Like, you don't have a lot of juice, I would say. But yeah. Yeah, definitely. I do want to do the same, actually. I want to focus on rendering and stuff right now. Because I want things to look beautiful, to, have more people watch and stuff, and be interested. And then I might, make tutorials on the few problems I've encountered, and what I did, like devlogs. But I wanna have like some kind of audience first, so I wanna make my game look good first. Yeah, Minecraft's biggest juice update is the visual effects. That isn't even that amazing. Yeah, it's kind of bad. I want some very nice rendering. So, observers. Yeah, let's go here. So I'm gonna have a list of observers, and I'm going to generate chunks around this, basically. So, observers, GD, get that. Here. I guess it's a typed array, actually. Yeah, I was using this, but yeah. Can I do that? Type array. I should be able to do it. Yeah, that's gonna be a lot better. So then I go here, and I implement getter setter. Actually, I'm not sure about it. I'm not sure about this. Get observers. Yeah, there's basically a problem. Array. Is it gonna be good? Explicit type is missing. Explicit type. Oh. Are you gonna make the model and music? Or are you gonna want help from other people? I'm probably going to, basically the goal is to have my characters be made out of voxels, for example. So, I do want other people to be able to make characters. I'm probably going to make a few ones on my own. Yeah, I would say, like, by default, I do it on my own. I'm gonna try to do it on my own. I'm not really thinking about the music right now, honestly. But I'm gonna try to do it on my own. And, if, like, there are some other people that wants to, like, add some content and stuff, then, I mean, I'm ready to accept any help, I would say. And yeah, I do want some what? Oh, I actually don't have this. Okay, I think I understand. I need the helpers. And incompatible, yeah. Typed array. Let me think. I mean, I know why it's doing this. Maybe add the type. Array type. Or like array. Well, typed lm. So this is going to be a typed array. And this is going to be the type. Well, this is going to be the type. Probably. So then we can go here. And we can put the type at the end. Getter here. Is it good? It's not. Error type. Is it? The set is kind of tricky though. I mean, I guess that's fine. No, it's not. You know what? Fuck it. Let's just not do it. I'm just gonna remove this for now. I don't need to overcomplexify things. It's JavaScript anyway. It sucks. Just kidding. Let's just have an array. So here we go. We implement. And now we need the bindings. Do with the bind. There. And here we go. Place observer, yeah. You really organize your stuff. I mean, like in bug notes and to-do list, I just find bug, fix bug, do more, find more bug and fix more bug. I probably should be more like, you're saying that, but that's not true. I am gonna do it because I'm lazy as hell. Yeah, I mean, I have this, but it's like not organized at all. I wouldn't consider it organized at all. Like usually what I do is I go on GitHub projects. Let me show you. I go on GitHub projects and I have something like this. And I have like a lot of tasks and do stuff, right? Like it's especially good with like, you know, if you're in a team, but I'm alone and I wanted to take a different approach because I saw a few people just take notes in Visual Studio Code. And I was like, let's try this. And that's why I would say I make sure my tasks are... Actually, I have some tasks that are useless, but they're at the bottom. So I would say that's basically mostly here. Generate, wait, this is actually done. Regenerate collisions. Let me first generate chunk visuals one by one, progressively. Okay. Yeah, it says there's an error, but there isn't. So let's say I have my observers. I want to... What do I want? What do I want? No! I'm actually not sure I want this. Yeah, that might not be what I actually want. Because, I was saying last time that it's actually the visuals that are supposed to drive, like the rendering is supposed to drive the loading. So, basically what I mean is I have my space. Oh wait, but that's, wait a second. Yeah, okay, never mind. I'm gonna have two different loaders. Am I? Ooh. But yeah, the goal is to have... Okay, let's actually put the class there. So this is going to have chunk space visual. This is going to have like a loader here. Chunk loader. I'm gonna have to leave because I have to do stuff. Happy to have text again though. Yeah, happy to. Come back anytime and let me know how things go with your games, with your projects and stuff. Can't wait to see you back. And yeah, once again, like if you wanna send the link of your game in the chat, feel free anytime. Bye bye. So we have the loader. we're going to have one in the collisions too. And basically, what it's gonna try to do is try load chunk, generate chunk. We're gonna remove this. And somewhere here. Okay, let's remove. Should we? I'm actually not sure. Wait a second. No, I'm actually going to keep this. Okay. So try load chunk and generate. Let's go here, maybe. Maybe not. Here. So we have all of this. Update chunk visibility. Oh yeah, it's like just showing everything, right? Right. That's probably not a good function. Why am I even doing this? Like, I remember there's like one place where I have like a try generate something. Chunk visual, I have a bunch of stuff. Cube chunk visual. Stuff. I have to clean things a little, but that's fine. Yeah, a lot. I have to clean things a lot, but yeah. I mean, I think maybe that's fine. Maybe that's fine. I'm probably going to have a loader everywhere, kind of. And loader visual, maybe split it a little bit more. So the visual is gonna be based on the render distance. Yeah, I might want like another class. Rendering, utils, collisions, core. It's wait, where was it even? Oh wait, I don't have my... Where is chunk loader? Voxel chunk loader. Huh? I don't have it. I just... Oh, chunk loader is there. It's on top of collisions. Wait. Oh, I have the two then. There. Let's have... two... chunk loader, maybe? And move it down. Is it with a S? No, it's not. Okay, good. So we have this. I want to generate what's around. That feels very visual oriented though. Yeah, let's create new ones. Chunk loader. So we are gonna have chunk visual loader, maybe. Visual loader. And we're gonna have chunk collider, collision, chunk collider, chunk collision, chunk shape. Collider. Yeah, chunk collider, probably. Chunk collider loader. Here we go. It feels like very specific to each place, so I'm not sure about this. Gisai is currently on a free stream streak. Oh, hey! Oh boy, I sure hope I don't get my sleep interrupted by someone. Sleep interrupting factory. Sorry if it's my fault. Yeah, I'm not a big fan of that. No, not you, not me. Oh, there's like a factory next to you, or no? Core. Let's go in core. Let's maybe put that there. And I'm gonna try to do the same for the other ones. So rendering, I have this. And then I have the collisions. I'm gonna have the same. So I can remove chunk loader. And let's go there. So we have, I mean, I basically, I guess the best thing to do right now would be to just go there. Maybe not go there. CD, well, actually I'm already at the root. Maybe not. Go do. And I just want to run this command because I feel like I don't have any debugging right now. And it feels like things are a bit hard to debug. So, no, not the target template debug. I want to try this. Profiler, that build is true. Target editor, I don't actually need this. But yeah, let's just do this. So many scams happening in Discord right now. Oh no. So isn't it quite dangerous to run people's game nowadays, since everything can be a Discord seal? Yeah, you're right. I actually heard about, yeah, the Minecraft thing. Yeah. I mean, yeah, it was on Discord, right? One of them asked you to download a Minecraft mod pack. Yeah, I actually had a friend fall for that. That's kind of sad. That, you know, trust is just getting lost. Like, just a few people doing that kind of stuff is, you know, it's gonna do that. Destroys the trust, and yeah. I mean, I guess that's why you have like Steam, for example, and stuff, right? Like Steam trying to veto those kind of things, and yeah. So then, because Discord is much a more personal thing than money market. Yeah, right. I mean, I guess you have like information, but that's not really, you know. Well, I guess you can say it. Maybe if you find like some good people, then you can like make threats maybe, but then you have all the legal side of things. Can you lower the music a bit? Yeah, sure. I'm sorry about this. I'm never sure. Wait. 1212, is it good? Thank you a lot for that. I don't really know. I'm just gonna go forward. It's like a bit too... Maybe like this. Yeah, maybe it's fine like this. A. So, yeah. Wait 2 seconds. Well, actually, let me... yeah, 2 seconds. Oop. Okay, I'm back. Sorry about this. Let's go there. So this is going to have a list of observers, and I'm gonna get... Basically, I'm just gonna... I did that for the collisions already, a little bit. Well, and I removed them. Update colliders. Yeah, there's a collision simulation group. So this is a bit different, but, well, is it? Yeah, it is different because it has... Well, this impacts the world, so yeah. What's your opinion on banana pepper? What do you mean? My opinion? I mean, basically, I'm the kind of person that's like the opposite. I don't put like anything on my things. Well, I mean, I do have some sauce for like the salad, but aside from that, I don't add anything to my meals. Like no salt, sugar just for the yogurt, I guess. But yeah, like sweet potato is like so good already. Like just eat sweet potatoes and you actually have like it's just so good, man. Just try it, man. Okay, just have like don't save. Just believe me. Make some kind of pot, like boil some water, put some sweet potato in it, like peel it, put a sweet potato, like cut, and then you can add like whatever you want, onions, carrots, how is it called? Things, right? And it's just going to taste very good because of the sweet potato. The sweet potato is all you need. The sweet potato is all you need, really. I love it so much. My life is sweet potato. Like really, like really, man. It's something. I mean, there are like different types of sweet potatoes though, but the ones I have are really nice. I only ate sweet potato like twice in my whole life. Yeah, I actually never ate sweet potatoes in France, but in Japan, I guess I wanted to like cook a bit more, like do things right. I was trying things out, and it's just so good, man. So basically, you have different kinds of sweet potatoes. You have these kinds that my parents find in France, I guess. But the ones I have are this kind. Right? So, like, it's a bit different. And, man, basically, it turns the water into some sweet thing. That's like so good, man. Just the water itself is good. Just the water itself is good. The water it got boiled in. That's crazy. My Latino? Yeah, Latino has. Do most vegetables with seasoning. Looks like the ones we have in Brazil too. Oh, try it out. Tell me what you think. Maybe I'm the only one thinking that because... Actually, never mind. There's like a lot of sweet potatoes things in Japan. Well, a lot. Satsumaimo. Maybe not meals, but how do you call that? Biscuits? Maybe not biscuits. But yeah, you have a lot of things that are inside filling. No. I don't know, man. Batata doce. Batata doce, Brazil. Oh, wait, what? Wait, what's that? That's a bit different. Wait, what? There's so many different types. That's crazy, man. Like, all of this is like the same thing. Multiple colors. Con esa os beneficios da patata doce. Okay, the beneficiaries, like the good things, well, the patatas. Les mêmes choses à savoir. The good things to know about sweet potatoes. Is that what it means? I don't speak Brazilian. I'm just guessing. You failed your class, a streamer. Never searched something someone asked. Why? Why? I believe in you. Means the benefits of sweet potatoes. Oh, got it. Yeah. Meat. Okay. But it's not meat, it's a fruit. No, sorry, it's not a fruit. It's definitely not a fruit. Okay. So... so now that I have my different classes and stuff, we're gonna go in the rendering here. And we're gonna do chunk visual louder. Okay. Then we have the same. Chunk visual louder. Okay. I guess I'm just gonna remove those things for now. I do want to include the chunk louder though. Let me remove this. This. Ah. Okay, so here we go. You're meeting with the knowledge. Oh. Call chunk louder. Yeah, I was thinking about the architecture. What about tea? Oh, I don't drink coffee. I used to drink a lot of iced tea in France, but not in Japan because the iced tea is not sweet. And I like sweetness. Basically, if something is sweet, I like it. If it's not, I can like it, but you know, it's like different. Like one of my favorite drinks is strawberry milk. Strawberry milk. I know that's very... yeah. I just like it a lot, man. Strawberry what? What? Strawberry milk. Does that exist in American? Yeah, this basically. Strawberry milk in Japanese. I mean, I live in Japan, so I've learned the Japanese name. I'm assuming that it's the same. That's yogurt. That's not yogurt. I mean, it depends. I guess this looks like a bit like yogurt. But I mean, yogurt to me is like not a liquid. To me, yogurt is like you know, there's like some texture, you could say. Not some texture, but it's like, right? There's like, it's a solid, basically. It's like a solid, very, well, not really solid, but it's still a solid. Whereas strawberry milk is like a drink. That's like a liquid. It's like a liquid. Creamy. I'm not sure about the creaminess, but... Strawberry milk. Let me mana. Yes, I buy this. This is at my store, at my local store. But it's not... What is that? What is that price? What is that price? What the... It's like 10 times what it should be. Oh, wait, there's 24 of them. Oh, 24 of them. Wait, that's actually worth it. That's so worth it. But yeah. Looks really sweet just by looking at it. I guess so. I don't drink it a lot, but sometimes like as a treat, I like it. It's like in Chiba-chan. That's like crazy, man. Chiba-chan is crazy. Strawberry milk. I wanna show you something, man. I guess it's a photo. So you have this, right? It's like kind of small, but then you have Chiba-chan. You have this. And this looks like this. And I'm taking this every time. I'm taking this every time, man. Because I don't drink alcohol. Because I don't want to. It's like... I was gonna make a joke, but yeah. And man... Chiba-chan is crazy. Like if you look at the karage, you have this, man. You have boats. You have boats of karages. It's like so good, man. What is that on top? Ice cream? Yeah, it's an ice cream. Well, it's ice cream ball. It's an ice cream. It's like vanilla ice cream. Right. Because it's a float. It's a float. The ice cream is floating. Float. 普通のな exactly, yeah. Yeah, anyways. It just... I love Chiba-chan. It's like very cheap too. Can you search recipe in English? Recipe for what? Just recipe alone. Wait. Like the strawberry thing. The recipe, I mean, okay. Strawberry milk. I don't know if there's like never mind. Or simple. Strawberries, sugar, of course, a bit of water, and a tall, cold glass of milk. I guess that's it. 3 ingredients: strawberry syrup, strawberries, cup of sugar, and some stuff. Korean. It's Korean. Well, it's probably the same thing. Strawberries, sugar, and milk. The one you like with ice cream. I mean, it's Chiba-chan though, so I don't know if like it's... I mean, probably not in English though. Chiba-chan... Oh. Chiba-chan. Strawberries, sugar, lemon juice, milk, and milk. milk and milk. I mean, it's missing the ice cream though, so I'm not sure that this is... Yeah, it's like not the same, obviously, but yeah. How do you even say recipe? Chiba-chan recipe. Strawberry. Well, strawberry milk. Can you search it in Japanese? 7-Eleven. Zippin. 再現するなら So, strawberries, sugar, lemon, milk, and condensed milk. So yeah, it's kind of the same. Well, it's saying the same thing in Japanese. But like, I don't think there's like a recipe that is like public. From the recipe, we have that in Brazil too, but we call it strawberry cream, not milk. Oh, I see. Probably it's the same thing. Like in France, it would probably be like strawberry juice, or I don't know. Maybe not juice, actually. Maybe not juice. I don't know. Yeah, juices. Maybe not. So chunk louder, okay. I'm gonna go here, and I'm just gonna comment this for now because I don't need it. So this is going to be referenced by the chunk space visual. So we have the loader, but this is just a chunk visual loader. And I mean, I guess never mind. This is going to drive things probably. Some fruits we call it vitamin. For example, avocado with milk would be vitamin. What? Oh, okay. Okay. It's for marketing. Space. I guess I actually don't need this, technically. I just need the update function here. Like, refresh around. Spawn chunks around, I don't know. More healthy, you know? Yeah. Tip. Refresh. Well, step, maybe? Maybe step is fine. Yeah, step is fine. Oh, is it? Maybe it's not. So I have my observers. Yeah, I'm not gonna do that. And what I want is I actually don't want to update every frame. I want to only update it when something that has been observed enters a new chunk, probably. Something like that. Or actually, I might want to step. Never mind, I'm gonna step. We're back at design patterns. Oh, no, not design patterns. No! Yeah, step. So when I step 1, 2, 4, observer. In observers. Yeah, it's called observers, but it's not a design pattern. Yeah, it's not. It's like an entity on my space. My space feels like the website, but no. I can't get it. Modules, Excel, core, observers, space observer. So we have this. We can get the. What can we get? Can get the space. Let me think. Okay, do I want one chunk visual loader? Oh, that's a nice question. Okay, okay, something to ask. Do I want? So, should I do one chunk visual loader or one chunk visual loader per space? I use a small amount of knowledge I have from game developing a state machine for most of my thoughts while coding, like avoiding redundant status fields. Wait. Oh. I use the knowledge for most of my thoughts. Wait, what? Redundant status fields. I'm trying to understand. It looks like a simple sentence, but I don't understand. I think I get it. But I'm not sure. But anyways. So, the pros. What are the pros? Pros, well, if you have only one, that means... Oh, that probably won't be good, actually. Like, with networking. Right? Because if you have a MMO, we might want to split instances. So we won't have an MMO, but it's like the kind of thing that would like block an MMO. Like block it, not really block it, but that would help a lot. Like we could split planets into different instances. And one chunk visual Lauda per space. I mean, I'm actually not sure. Wait a second. Yeah, right now I'm assuming a player is only in one space, which might not really be true. Like on one planet, basically. I'm assuming it's on one planet. But what if, like, for example, there is the planet and then there's a vehicle, right? I want to spawn the vehicle. Is your game two instances, the server and client like Minecraft? It's probably going to be a client server. Well, the priority is the client server, but you know, it can become a server client. I mean, it's, you know, it's like just it depends on what I do, I guess. Like if it's needed, I'm going to split it into server and client, but you know, like I'm splitting my visuals and stuff already, right? So like if I want to make it into a dedicated server, I just have to remove the visuals for the server. So it's like not that much of a deal. Like it should be quite simple. Well, the only problem is like hitting, I guess. But yeah. For like cheat. But let's not talk about that. One chunk visual loader. So basically we can load chunks from different spaces more easily. And in this case, it can be optimized for each different space. Can be optimized for each different space, maybe. Because we can get the coordinates. Oh, right, it's about the coordinates. Oh, right, it's about the coordinates. Oh, no. Right, if it's about the coordinates, then I have to... difficult if different coordinate systems. So I'm more inclined towards this. I'm probably gonna do this. Let's do this. So right now it's a chunk visual loader, but it might become like cube chunk visual loader. Okay, so we have this. We step. So we assume that the space is the same, or like cube chunk space, let's say. Space. Oh wait, actually, that's actually... You don't use pragma-onth. It's Godot. It's Godot is... Like, everything is Godot is like this. Usually I use pragma-onth, but Godot doesn't use them. So I'm... Anyway, so I'm using them. So... wait a second. I'm sure it was in modules, okay? If I go in if I go somewhere else, like in Notch, Like, Nudge doesn't have that. Look at this. That's gonna go in a clip. That's gonna be a clip. I don't know. That's gonna be something. Anyway. So I have an observer. Actually, yeah, let's make a custom one. Let's go there. Chunk visual load. Wait, what? Oh, in rendering. Yeah, that's fine. Loaders. So we're gonna move that there. And you're gonna have cube chunk visual loader. That's a lot of classes, I know. That's fine. Oh my god, how do you plan on multi-threading? What do you mean? I'm just gonna whoop, multi-thread. Just, you know, whoop. I mean, basically right now, my collisions and my visuals and the core, like the generation is like very split. So I can like multi-thread however I want. I'm not doing it right now, but like there's no issue if I wanna multi-thread things, I would say. Like I can dispatch a new task every time I want to generate a new chunk, for example. That might be a bit overkill, but yeah, for example, if I have a list of chunks I wanna spawn, I can add it to like a task, to a thread, to a worker. I can assign it, and boo, here we go. Like, I don't know why there would be a problem with multi-threading. Like, basically, what should I multi-thread? Obviously, I don't want to multi-thread the gameplay, because, like, the gameplay is, like, interacting, right? So I can't really do that, because otherwise there would be, like, mutexes everywhere. So I might want to I might want to multi-thread the generation. In this case, I already have my cube chunk generator class that is here, and I have this function that is like almost independent. I guess I'm just what? Well, right now I'm setting blocks directly, but like I can just like have an array before and then like still move it into the chunk, and like at the end when the task is finished, then I do the register chunk. So it's like that's really a problem. Render should be in a different thread. Oh, that's like Godot though. That's like Godot. Like it's already in Godot. Like the render thread is already something unique, and like my pipeline is my render pipeline is already technically maybe in a different thread depending on the settings you give to Godot. So yeah, it's not a problem. I mean, same for collisions, you have that, but you know, it's in Godot, it's like already in the engine. That's not something I have to do. That's something I have to take into consideration, but yeah. This engine is gutted, is it? I mean, yeah, it's, well, there's just, I just hate arrays, but that's fine. That's like the only thing I really don't like with Godot in C++. They just suck, man. With like the cow. Copy and write. I like how you have Obsidian in your taskbar, but use VS Code for nuts. I just don't use Obsidian. Well, actually, I use it to write the Japanese words I don't know, and then I just don't do anything else. I just write, and I don't read it back. So yes, it's let's go. Let's remove this. Maybe it's going to be a virtual. Actually, let me do this. Wait, that might actually be good. Maybe I won't have to create. Well, I already made it. That's fine. That's fine. So basically, wait, is it? Shit. It's made a new one. Okay, let me just refresh this maybe. And what I want to do is I want to get the chunk. And the chunk is going to have an ID. Because for non-Euclidean spaces. And from that ID I can get like neighbor chunks. And maybe I can do things with that. Well, I want to load them from this. But let's see how it goes. What about the overhead? Should be good. Are you doing version control? Yeah, I am. I'm like every time I have like a nice state, you could say that I finished something kind of neat. I make a new commit so I can make a video about it in the future, like a devlog or something. So let's say I have one chunk. So I want to get the player's chunk. And then I want to get the neighbors. Okay. Yeah, that's going to be a bit complicated actually with the transformations. But yeah. Okay. Yeah, that's going to be a pain. Maybe I don't want that. No, it does. Okay, we have this. So I mean, a very simple. Let's do that in here actually for now. Let's have a very basic implementation. Get chunk chord maybe. Coordinates. Let's get chunk ID. Maybe not. Yeah, that's a problem. So the player should always be in a chunk, I think. Like, I don't think there's like any other way. But then how can I load, how can I generate the first chunk? That's like a problem. I'm trying to make things compatible with non-Euclidean worlds, but this is a bit complicated even for me. Because it's like two different logics. Like in an Euclidean world, you would like compute the chunk coordinates based on the player location, but on a non-Euclidean world, you would say that the player is always in 0, 0, and that means it's always in like a local chunk. And you get the chunk it's currently in. So it's like two different kinds of thoughts that I have to switch. Get current chunk. Actually, never mind, I can just do that. Chunk. No. Yep. Space. Let's just have chunk. Get current chunk. Whoa, there is a subreddit for voxel game dev. I actually saw it. I know. I saw it recently. I wanted to send a few things there, but I wanted my game to look nice first. So, you know, people get interested, I guess. But maybe I should like post a few things from time to time. I don't know what you think. Do you use Reddit a lot? I don't use it a lot. Wait. Return current chunk. Yeah, maybe this is good this way. So we have a chunk that is already loaded. Because even if I have like an ID, it wouldn't really amount to much. So let's have this get current chunk. I mean, I guess it's a const. So I can get the current chunk. And then I can try to get the connections. So I need to include cell core chunks. Yeah. Chunks. Ah! Chunks. Chunk. So here we go. So then I get the chunk, the current chunk, and I'm assuming this is always valid. It's not. I'm just gonna AFL null. But if this is null, it's gonna just not work. Okay. So chunk. Okay. And if this, let me just verify that this is null. Yeah, okay, this is null. And if this is, I guess it depends on the space though. Space observer. Yeah, but it's like an observer for a space. So that should be fine. Right? Yeah. So think now I want to get the connections. Get neighbor chunks. Something like this. And this is supposed to return an array of chunks. Maybe I'm just gonna have like a local vector. Okay, let's say I have my new chunks, like a local vector of chunks, neighbors. Then I'm going to try to generate some get neighbor chunks. Let me actually think a bit. Because I have some optimization. I have some optimization in maybe cube chunk. I have this that's checking if like there's a like it's fully opaque on one side, that kind of stuff. So maybe I'm gonna have like a virtual function about it. Like should generate, for example. Or maybe that's actually just going to be neighbors. Oh, I don't have that. Cube chunk neighbors. Where was it? Neighbor block. And neighbor chunks. So it's in chunk space. Oh, right. Okay, I guess it's there. So I guess it's in the space. I mean, it's supposed to be the same. So I'm just gonna verify that e equal. I guess it's a condition. And I'm gonna verify that the space of this chunk is equal to the space I'm observing. Incompatible. Cube chunk space. Chunk space. Cube chunk space. What? I guess it's because I'm just forwarding. Yeah, let me just go there, and this is just going to be a chunk space. So now it's good. Now it's good. Now I can get the amount. The space gets NB neighbor chunks, which is an amount. I mean, it should be like, it could be a uint 8, but yeah. So NB neighbors. And then for all of those, I'm gonna have should generate. Should I? Like chunk should generate neighbor. It shouldn't really be. I don't really like this because it's like a function from like is visible, is neighbor visible, is hiding neighbor. I guess is hiding neighbor, maybe. See ya later. Okay. Bye bye. Thanks for joining for a bit. So I can have this. So that's why I don't have a list of chunks. That would be kind of bad, would it? I don't know. Like this, I equals 0. I is less than this. Well, it's actually neighbor. That's what's neighbor. True. Here we go. Okay, so we have all of this. Is hiding neighbor. So for each neighbor, I'm gonna check if this is hiding or or if the neighbor is already loaded actually. Is neighbor loaded? I mean, I do want a reference to the chunk in the end. So yeah. Like I'm just gonna have local vector, maybe, chunk. Yeah, that's basically what I had. Get neighbor chunks. If, well, let's not make a copy. If this neighbor, if this is null, so if it's not loaded and we have this, and well, and it's hiding the neighbor, or it's not hiding actually. If it's null and it's not hiding, then I add it to the list of chunks to generate. So, for example, let's make a local vector again. To generate. We're gonna push back. So there might be a few like some small multi-thread issues right there, but yeah, I was thinking maybe I should divide, like split this class, split the core with like data specific to the loading part, but I'm not sure. Maybe not. Maybe not. Probably not. Never mind. So I want to push back the current chunk. Well, I don't have it actually. So I guess it's going to be a connection from this chunk to the next chunk. So chunk path. So I get the amount, I do the thing, I push back. And yeah, this is probably gonna be chunk, not connection, but chunk card, maybe? Oh, wait, this one is a bit different. Well, let's say chunk card. Card. Maybe. Chunk coordinates. Not sure about this. Chunk path. Chunk path. And yeah, I'm not sure how to test if like two connections are equal or not. I mean, I guess it's going to depend on the space. But basically what I wanted to do is like wait, source path, neighbor chunk, maybe neighbor chunk. So we have like n dot source equal this, and the neighbor index equal neighbor, something like this, and then I push back. I would say that would work pretty well for non-Euclidean things. I just have to. Yeah, let me get something. Let me try GPT in a non-Euclidean world. How to test? Well, I can define a chunk to be the origin chunk plus the index of the face of the face connecting to it. But my question is, but how can I compare easily and fast? That's two different paths are pointing towards the same chunk. So what problem in your group? Euclidean world chunk, a chunk coordinate gives you a unique representation. Yep, it's just a path which reaches the same cell as this. Yeah, because of the tiling symmetries. Yeah, canonicalize path. Treat each phase transition as a generator. So go through phase 0, phase 1, phase 2. Then define the relations of your geometry. Oh shit. Whenever you append a step, reduce the word to a canonical form. I'm not sure about that. And then I just compare the canonical path. Extremely fast because the expensive work happens incrementally as you work. how many hyperbolic rendering engines work. Store an isometry matrix. Instead of storing the path. Wait. Yeah, this is not the path. So relations. Oh, never mind. Oh, yeah, it's a relation. Okay, I get it. Yeah. Maybe. Storing as math. Ew. So I don't want floats, basically. Instead of storing the path, store the transformation from the origin. For hyperbolic geometry, where each mi is a matrix corresponding to crossing a face. Then to transfer equal if A transform equal B transform. Unfortunately, floating points. Matrix comparison are expensive, and exact equality does it. Oh, yeah, okay, I get it. Yeah. Assign IDs lazily. Whenever a new path is found, canonicalize it, look it up. If absent, create a new chunk. Yeah, but how can I look it up? Then, well, yeah. Every chunk gets a unique integer ID. Automatic groups, finite state automata. I mean, I think that's basically the thing I was thinking about, because all of that has the problem of using floating points, right? Go through Defines the relations. Yeah, I'm not sure about this. Many regular non-Euclidean tilings have an automatic structure. For example, this. Have finite automata that can reduce path to a unique normal form in O length of path. Yeah, it's gonna be a bit... Well, it's gonna depend on chunks. This is how games like hyperbolic roguelikes... and mathematical software handle navigation. Wait, what? That exists? Hyperrogue. Yeah, okay. Wait, never mind. A unique subgenre of turn-based RPGs. Wait, you have multiple ones? Hyperrogue. Yeah, okay, it's actually the only one. The crown jewel and defending title is Hyperrogue. Yeah, this one is crazy. I love it so much. Horror cycles? Oh. The amount of cells in distance at most d from the starting point is exponential. Yeah. Grinding. Yeah, this one is nice. So an idea in a transform. Never compare transforms. Never compare paths directly. Yeah. And this is the matrix used for rendering. I don't want that. Compare only this. I don't want to compare plus. I want to process path. Yeah, what about this? O length of path. How games like Hyperbolic? Yeah, I like it a lot. Handle navigation. Have an automatic structure. Many regular non-Euclidean. Do all non-Euclidean tilings have an automatic structure? What does that mean? And how to reduce to a unique path? I mean, I guess it depends. But anyways. No. Most regular tilings that you would use in a game do. This is automatic. Yeah, this is normal. This is Euclidean. Yeah, Euclidean square grid. X automatic, hyperbolic automatic. There are pathological groups and manifolds where the word problem is much harder and no finite automaton exists. Suppose chunk coordinate is this, represented as this. Another path may be this, and both end up in the same chunk. An automatic structure is basically a finite state machine that can read a path and convert it into a unique normal form. Well, I think I understand why there's a problem. Never mind. Means this becomes this and this becomes this. Good. That's what I want. Now equality is simple. Yeah. Hyperbolic example. The path containing this can be removed. Likewise, this can be removed. Wait. Going around the vertex 4 times returns to the original orientation in 5-4. Okay. Eventually, every path reduces to one canonical path. Just like this. How do you find the rules? Coxet our group. These groups are automatic. People have already computed the automata for many of them. BFS. Yeah. On neighbors 1. Unexplored neighbors layer 2. First time you encounter a chunk, you assign a new ID. After that, I compare. But wait. Oh, but then I have the face. Wait, that's a... Is it good? It's gonna explode if I do that. Isn't it? Like I have a chunk 0. All the chunks around are gonna have an index that's gonna be like the face. Like 1, 2, 3, 4, for example. And then I have to do things based on that. I can't really do that. I do. Called a normal form. Yeah. I mean, technically, it's not to exist. Technically, I should just be able to check every... Or maybe not, actually. I need a function that checks equality. A coordinate. And yeah. Yeah, that's a bit difficult. Chunk path is hiding. Mm-mm. Yeah. I could have a pointer for the coordinate. Like a hash. Not a hash, but a pointer. Not really a pointer. I don't really want a pointer, but yeah. um. I mean, I guess I just want the coordinates, but it's a bit complicated. It's a bit complicated. Get chord. I need like a pointer, like an index or something that represents a coordinate. So I can have things a bit abstract. Like some data, some bytes, I don't know. But it's gonna be slow if I have bytes and stuff. So I'm thinking about having how do you call that? I mean, pointers is kind of fine, really. Maybe it's just an index. A coordinate. A chord. Like if I have class A chunk chord, for example, abstract chunk chords, something like this. It could be a pointer, it could be an integer, it could be so many things. Let's just say it's a void star. Well, or maybe a size t. Okay. So let's say this is, well, actually it's a size, right? Like a size, u size. Does that exist? Maybe not. Just a size. It's already, wait, what is this? With an eighth? Wait, that's not what I want. I size. I size. Size I. Size I. Size T. I'm not sure about this. Let me look at this vector. What is size? It's what? That's not true. That's supposed to be a type, not a function. So u size though I could have. So u size, for example. Maybe not. Oop. Type def. You know what? Let's go with uint64. So okay, we have this. We have coordinates. And that's good. And that's just good. Maybe. Then we're gonna do... It's kind of like a string name, I feel like. I'm gonna use it kind of the same way. So I can get the neighbor chunks, kind of. I can get the well, check this. Then I can have the coordinates, chords, and this should be equal to the neighbor. So to neighbor chords equal right. Right, wait a second. I still need the connection. Do I? Like to generate, can I have to generate? Well, chunk to generate. We have generated from. We have the in32 neighbor ID. Well, neighbor ID, neighbor index. And we also have like the, I guess we can compute the coordinates after that actually. Or can we? Because it depends if like it's already loaded or not. Like if I can get the coordinates and ensure this is not loaded already, then yeah. Then yeah. Let me have this in like the header file. So I'm gonna have a list there to generate. Then I want to push back this. So let's just go. That's actually what I want, like there. To gem. Boom. Boom. We have the source and generated from. Oh, okay. Wait, inaccessible? Right. Public. Well, it's actually already public. So it should be good. It's a chunk. Well, forward declaration. Then we add it to the list. And I want to filter that list. Well, I'm already filtering it, I guess. So chunk to generate. I guess I can just call it like a virtual function or something. And if well, if it's already spawned, well, it's already loaded. Then if it's not, I mean, I'm gonna push back. That's basically gonna be it. And yeah, this one is gonna be a function somewhere, like here. Virtual void this. Well, is loaded. Is chunk loaded. Is gonna take this chunk to generate. Chunk to generate. Well, chunk to generate, yeah. Okay. So we can just override this in kubechunk visual, and it should be kind of fine. Boolean, right. Had to return a Boolean. Then I push back, if this is good. And after I push back, I can try to generate everything. I have to score things too. I need like a score. Hmm. Well, is neighbor loaded? Maybe is neighbor loaded is better. Is neighbor chunk loaded? That way I can compute coordinates. So I have the chunk and the neighbor index directly there. Neighbor index. Okay, good, good, good. I like it. And if this is good, then I can just... Well, I guess I can have this in the if. And it's not already loaded. Yeah, let's have it maybe a bit before. I mean, actually, this is already trying to check this, right? Neighbors, neighbor. Let me think. If this is null, I mean, I might want to find it from... to look it up from the disk. Right? Because if it's null, it might still be saved on the disk. So, in that case... maybe not loaded, maybe generated. Because obviously it's already... what actually is it? Maybe it can be null. Can it? So when I spawn a chunk, I'm gonna check if the neighbors are good or not. Am I? I think I should. But I feel like this is gonna be pretty slow if I do it like this. I don't know. Is neighbor chunk loaded? What about generated? I mean, that's kind of the same in a way. Maybe find neighbor chunk instead. Yeah, maybe a find neighbor chunk. So I have this, I loop through the neighbors. And I do a find neighbor chunk. Find neighbor chunk is a chunk. So here we go. And this should become equal, basically. And if this is still not good, then that means it's not there. But the find, I'm not sure this is like required. This should become something the moment it's loaded. So I'm maybe just going to verify neighbor. I'm just going to verify chunk. Wait. What is that? Oh, right, this neighbor chunk. I'm just going to, well, let's do a elf file count. If this is different from now, it's not working. And then I want to load this chunk. So, okay. Okay, so that should be good. This should be true. Well, this should be set as soon as the chunk is instantiated. That should be updated. So a chunk not loaded is always null. Well, it's the opposite. So if null, the chunk is not loaded. That's basically it. I mean, I could make like a function inside the space. Maybe not the space. Inside the chunk. Let's go into the chunk. So we have this, we have this. I'm adding a bit of overhead, but that might be fine. I have the neighbors. I have NB neighbor chunks. Wait. Oh, get neighbor chunks, never mind. So here we go. I just return. Well, I guess I do. A const. I guess it's fine. Then is hiding neighbor. This one should be in here, probably virtual. Perl is hiding neighbor. And I do stuff. Well, by default it's like, no. But it's like, it can be overridden. For like optimization. Override for optimization. And it takes a uint32. Neighbor index. Yeah, I'm gonna say that this is a neighbor index. So I have this. I'm going to find hide, okay. Find neighbor chunk. Generate from. Okay. So then I have this in the end. So it should not be here. Oh yeah, but I have to... Never mind. Okay. Yeah, what about the generation? If I want to multi-thread it, I want to... I'm not sure. I want to ensure they're unique. Like maybe just a function remove duplicates. Remove duplicate. Yeah. Remove duplicate chunks. I don't know. But that means I'm gonna compute and then the result is gonna get discarded. I mean, I guess that's not bad. And then I want to, for all of this, into generate. Well, to 10. Let's just cut it. Then we are going to have the. Well, we try to check if this is on the disk. If saved on disk, then we load from disk, right? And else, if this is not generated, I mean it should not be generated. So this should be just a generate chunk. And after we generate the chunk, what do we do? What do we do after that? I mean, I guess it's gonna spawn. So we're gonna have the chunk, right? And we're going to have to set the neighbors. So generate the chunk. I mean, maybe in generate chunks we're already going to have the neighbors. I don't know. Maybe not. So basically for chunk. Well, I'm gonna do the same thing here. Env neighbors. It feels like it's gonna be a bit slow. I mean, it's supposed to be async. That's not supposed to be the thing that's gonna take the most time, I think. But I don't like how there's like an array of neighbors, but it's like kind of needed for some geometries. So I guess that's fine. And that way I can have like very custom and special non-Euclidean geometries. Which is good. I can have like some kind of portals, basically. Yeah, that's actually very trivial. That's actually great. Wait a second. Oh, that's actually so great. Yeah. Oh, but it won't be possible. Hmm. No, that should be fine. Yeah, that should be fine. Yeah, because if I block the generation, like his hiding neighbor, that should be fine. I should find a way to load what I want to load. Maybe not. No, never mind, I can't. Well, I would have to despawn the chunks I am thinking about. Or should I? Oh, no, that's fine, actually. Oh. Okay, I can actually make some non-Euclidean geometry. I just have to be careful about the rendering. The rendering is the only difficult part. But aside from that, like, conceptually, in the module, there shouldn't be any problem. Yeah, that's a rendering issue. That's a rendering issue, but I can have non-Euclidean worlds, like fake non-Euclidean worlds. Well, fake. Portals, you could say. Mm. Mm-mm-mm. As long as it's scaled, there's no problem. But then there's the portal thing. I mean, I might have both. But yeah. Mm. Oh, like for example, for my donut, I can make it go from one chunk to another, technically. I can connect the different chunks. If it's even. If it's even. From one side to the other side. But it just has to be... I just need more chunks. But I can technically do that. I can technically do that. The gravity is just going to be a bit weird. So it might not be the best thing to do. Yeah, maybe not. Hmm. Mm-mm-mm. I'm thinking about how I can use that. And it's a bit complicated. But well. But well. Hmm. Yeah. So in the visuals, if the neighbor is not at the place it should be, what about... Conceptually, there's no problem. But if I want to render that... Right now I'm rendering chunks from the chunk coordinates. I'm just multiplying. So it's not a big issue. But... should I compute from the... I should compute from the player's perspective. Always. If I do that, then I can get the chunks that are the nearest to the player. And I can do a few things. Yeah, it could be good. It could be fine. Could. Then I can sort by the distance. Um, And I render the ones that are the further away first. I will use a stencil. It's a bit complicated. It's a bit complicated. I mean, ideally, I just don't want to render the chunks that are behind. If there's some occlusion. And I always render from the player viewpoint. Like from the origin that is like moving. Which should be the player really, but yeah. Yeah, I mean that I'm gonna have to change my pipeline. But okay, this is actually good. I remove duplicate, I load. I generate the chunk. I have the amount. And yeah, this. And I'm gonna set the neighbors. So get neighbors. Maybe neighbor, well, this set neighbor. Let me think for a bit. I mean, technically the opposite should be true too. Set neighbor. Neighbor index. And I want to find if this is existing or not. So finds neighbor chunk. Yeah, this is it. Neighbor chunk. And if I find it, then I can set it. And it should do the opposite too, should it? Maybe neighbor chunk, set neighbor. Yeah, but yeah, what side is it gonna be? What side is it gonna be? If it's like +1, then it's -1. Neighbor index. So 0, 1, well, 0, 1, well, 0, 1, 2, 3. So then we just do a -2, or like a +2 modulo 4, and it should be the opposite. So that should be fine. Set neighbors, or like assign neighbors. Link neighbors. And it's gonna take the 2. Maybe like in some kind of schema, like a graph, like with nodes. So. Yeah, maybe that's just going to be a static function from chunk. Yeah, that is probably better this way. Link neighbors. Yeah, that's better this way. So we have a chunk. We have the neighbor index. And we have the neighbor chunk. Set neighbors. Set as neighbors. Oh no, wrong one. So this one, for example. We're gonna go there. We're gonna set as neighbors. So we have those, we have, that's a static function. That's a chunk, star. Same here. Same here. Neighbor chunk. And I'm just gonna have neighbors. Neighbor index equal this. And then we're gonna have the matching face, like the matching index. So, I mean, maybe it should be virtual actually. No. I guess virtual is better. Or is it? No. Wait, that's half. Oh, wait, I get it. I think I get it. It has to be... Wait, it's a bit complicated, actually. So if I have non-Euclidean geometry tessellation, okay. So let's say we have this shape. The neighbor is this. And okay, we only have 4 faces. So we do a +4 modulo, well, +4 half, like half of 4, so 2. And we modulo. So what about this one? We have a triangle. 1, 2, 3. So we go there. It's going to be half. Is it? Can you get half of a triangle? You can't. That sounds a bit complicated. Because the faces are not going in the same direction. Right. That's a bat. Oh. So I'm not really sure. I think it's like an offset, but... So, this one. I go there. So, 0. Yeah, let's actually go in on paint. So we have orange. Yeah. We have this. Let's go here, for example. So this is going to be 0. This is 1. And this is 2. Then we get here. What is... I mean, I guess I need like an offset. So like maybe if it's 0, is it 0? I don't get it. I just have to find the matching phase. So if I do a plus... Wait, if I do a plus... Wait, what am I doing? I just have to find the points that connect. I don't know what I'm doing. How would I even define this geometry? That's the problem. I can't define it globally. So locally. What is this triangle? I mean, that's like a source. So maybe 0 is always... Maybe not. I was gonna say 0 is always the one you're coming from. No, never. Never do that. Yeah, it's actually a bit complicated. Yeah, because there's no global coordinates, right? But it should share the same vertices. Why is it so complicated? What the fuck? It's about definitions. It's complicated because of definitions. 0, 1, 2. So if we assume that this is always 2, I guess we can assume things. If this is 2, if this is 1, if this is 0. I mean, there's just going to be a lookup table, basically. So there's just going to be a lookup table to set. So this is a set or not? Wait, what? Static. What was I doing? Virtual? No, not virtual, never mind. Neighbors. Clear, nah. Yeah, let's just set like this, equal this. Oh, it's an int. Right, this is an int. Neighbor chunk. Wait, what? Wait, that's wrong. That's the opposite. Okay, here we go. So wait. Maybe let's just have this one first. Okay. Then we do this. We set this. And then we need the conversion table. So we have the neighbors. Neighbor index conversion table equal the current chunk. Okay. And this table is basically going to be uint32. Oh no. I guess that's going to be a local vector. I don't like it. Or maybe a function. I mean, I guess it will be like optimized this way. I mean, this is actually in the space. It should be in the space, shouldn't it? I think it should be in the space. Yes, it should probably be in the space. Chunk space. NB neighborhood chunks. Something like this. I'm just gonna get this. get neighbor index conversion table. I'm just gonna return it. Okay, the reference. So now I have the conversion table from the space, I suppose. Maybe I need the... I'm so not sure about this. Maybe I don't want this. Like neighbor index, a neighbor chunk. And it's just going to have the other thing. Source index. And other index. So it's basically just going to be this, and it should be fine. Right? Expected? What? So yeah, it should be fine. And now I can delegate the problem to here, where I have to get the space, I suppose, and get the table, and get the new index. Like this. Like there. That's big. I can technically just do that. Let's just have a uint32 of that index. So now I can set them as neighbors. Okay, good. For everything, for every chunk near it. And yeah, should be good. Find, nah. I generate the chunk. Load from disk. Actually, I want to do that when I load from the disk too. Yeah, let's do that afterwards, like here. Because in any case, we should have the chunk afterwards. Actually, not if it's multi-threaded. Like it should be load from disk like this. And when this is done, on chunk loaded, it's gonna be another function. When this is loaded, I want to update the neighbors. Or like on chunk loaded, I'm gonna have the new chunk, and I'm gonna have the source. I do want the source. So I guess it's gonna be here. Good gen. Do I want this? Actually, it's the generate chunk. I do want the information about the neighbors, but maybe to gen. Yeah, okay, that should be fine. Actually, I already have the information there from this. Wait, so this to gen, we have the chunk. That means we can add it in here. Save on disk. I basically think this is going to be a critical like a part that is going to be critical in speed. So I'm a bit afraid about it. That it's going to be too slow. But I mean, it can be fine. It can be good. Especially if we optimize this. push back, no, remove duplicates, to load from disk. And yeah, every time that's just going to be the unchunk loaded at the end. So I close from disk, unchunk loaded. To gen is gonna be this. So I can just give it right away. This is going to load the chunk, so chunk like this, let's say. We have something and we then call this function. And that's going to be the same for the generate chunk, really. Oop. Load from disk. Yeah. Same here with generate chunk. Saved on disk. Is on disk. Who is on disk? Maybe it's just load chunk actually. Well, that should be fine. Const. Yeah, I'm actually, it's not really optimized. It's not optimized. Let's just have a load chunk. Load chunk. And this one, is it going to be virtual? I don't know. I mean, yeah, because I guess I can generate it, or I can just load it. And if I don't want to load it, I can just generate it every time. If it's like some world that is not, where you can't place anything. Is that really gonna happen? Load from disk. I guess technically we could do that. Yeah. Who? Wait, what? So we're just going to load the chunk. To gen, yeah. This is going to be something like this, I guess, by default. And at the end, in any case, we have the unchunk loaded. I need a unique identifier though. I need a unique identifier. Chunk ID. I think I'm going to need it no matter what. Yeah, am I even using this in the end? I'm not. Yeah, it's basically a chunk ID. And this one is gonna be... is on disk. I guess try load from disk is fine. But what if it's like multi-threaded? Should I do things a bit differently? Like 2 loads from disk and 2 generate. And there are like 2 different queues that run like multi-threaded. So we have less of a context switch. I'm not sure about this. But I mean, in any case, right now I don't have this. So let's just try load from disk. Generate chunk. Yeah, let's load it from the disk. Is on disk? No. I mean, let's just generate right now. Actually. Yeah, try load from disk. We have this. And if it fails, it should do something else though. I'm just not sure about this. Like, what happens if it fails, and what happens if it's async? If it's async, I can't do that basically. So maybe. Let me check something. So when I want to load a chunk, I either want to load it from memory, from the disk, or generate them. Performance-wise, taking into account multi-threading, should I try to load each chunk individually, or should I split them by loading type and then load them as a batch? Is there going to be any difference of the performance? And like dash, well, for example, cache, multi-threading techniques, well, optimization techniques that I don't know about, etc. Method. Usually you want to split by loading type. Yeah, that's what I was thinking. And batch similar operations together. There are several reasons per chunk pipeline. So I can do this. Oh, that's actually exactly what I was doing, kind of. Advantage is simple. Lower latency for a single chunk. Disadvantage is constantly alternate between file system operations, decompression, procedural generation, memory allocation. So it's like hard to parallelize. Yeah. Poor quality. Yeah, I don't know if I can like multi-thread the loading very fast. Like, can you actually multi-thread a file loading? Can you multi-thread loading a file? Well, different files from Windows. Yeah, okay, you can. Isn't there single hard drives, SSDs? If you're reading many files from a traditional spinning thing, multi-threading will actually slow things down. The red head will trash, as it is physically jumps back and forth to service multiple threads. No parsing required. One thread to read sequentially, and multiple threads to process and parse. Makes sense. Yeah, okay. lower latency for a single chunk. I mean, yeah, because it's multi-threading, yeah. Yeah. Harder to parallelize, poor locality. Yeah. Batch per type. Usually faster. This clouding benefits. Wait, what? It's a different part. Well, it's the same thing? Well, never mind. Reading this together is much cheaper than this. Especially on HDDs, is it? I guess it's sequentially, right? Because of the context. Even on SSDs, fewer syscalls, better OS read ahead, and fewer context switches. Compression. If chunks are compressed, compressor code and lookup tables stay hot in cache. I guess so. Generation benefits. Noise generation often looks like this. Yeah. So yeah, you can optimize things. Well, if chunks are compressed, the compressor code and lookup tables stay hot in cache. Yeah, this is good. Generation benefits. If all worker threads are generating the same things, instruction cache utilization improves. Of course it will. Better thread scheduling. 20 disk chunks, 20 generated chunks. Per chunk scheduling. Some threads block on I/O while others sit idle. Yep. Wait. I guess. Does it? Batch scheduling. Load. Generate. Well, I/O thread pool. Yeah, never mind. In games, pipelines, the pipeline becomes this. Each stage can have its own thread pool. Another optimization, existence lookup. Oh, by opening the file every time. Oh, don't do this by opening the file every time. Maintain this loaded at startup. Yeah, you already have this. Then if it contains iLook. Okay, I didn't know that. I didn't know about this. Makes sense though. Usually minor compared to... Okay. File system latency, memory allocation, decompression, noise generation. Biggest gain comes from... I mean, I don't know about this, because... I mean, if I have multiple threads, I'm not sure about the cache. Reducing synchronization. Reducing context switches, increasing sequential work. Wait, what? If it's very expensive, then it can be beneficial to interleave loading and generation to reduce latency. I guess so. Batching by job type is almost always a better design. Okay. Yeah, let's try this then. Let me think. I guess I would need like a database, or do I? Like maybe just is on disk to gen. If it is, I'm going to add it to a list of local vectors. To load from disk. I mean, I could have an index right now into this, but yeah. Wait. It's actually gonna be kind of bad, I was gonna say. For every... Wait. So I get the current chunk. Right? Chunk. But that's it? What about the ones after that? Oh, right. Yeah, okay, that's the amount of... Okay, no, I get it. I need an array of chunks that have to be processed. So if it's this, if it's on the disk, to load from disk, push. Else, let me just check one more thing. In multi-threading, is cache really that important? Isn't there going to be a lot of context switches because the OS goes from one logical thread to another? Okay. Less frequent that I might think. Oh. Does not flush the cache. Oh. L1 and L2 are not cleared. Yeah, but it's gonna... When it's gonna do something on another thread, then there's going to be a problem, right? Wait, oh, wait. May still be in cache. Yeah, may. Thread migration. L1 is gone. No. Oh, because it's like in different cores. Oh, so it's about cores, right? Right. Ooh. That hurts. I didn't know that. I didn't know the scale. Bounces between calls. No. Chunk engines synchronization costs are usually worse. Wait. Then context switches? Yeah, it's this. This can force cache coherence traffic between cores. Okay. Avoid oversubscribing threads. Batch similar work. Keep data local to each worker. Minimize shared writes. Avoid false sharing. Assume cache behavior matters enormously. Okay. So I'm gonna add this. I'm gonna have another list to generate. Actually, it's already to generate. So this is gonna be a to load. Then I have to load. To generate is gonna be here. Push back. To gen. It's not really to gen, but yeah. Junction. Something like that, basically. So to generate, okay. And then at the end, I have all of this. I might want to take care of the what? I mean, I do want to take care of like the closest things. I want some kind of scoring. I want some kind of scoring function. But maybe not now. So for now, I'm just gonna generate, maybe? I mean, generating became kind of like slower because of the noise. I don't know about that. To generate. So I'm just gonna generate this. Actually, loading may be faster than generating. That's why you save it, right? It's loading a chunk. But well, from disk, normally faster than generating it. On Minecraft. Simple procedural generation. It's often faster. Yeah. A few thousand noise samples can be cheaper than all of that. Minecraft can generate terrain very quickly. Okay. Expensive world generation. It kind of depends. Yeah. Cave cellular automata. Then generation can be orders of magnitude slower. Microseconds. Yeah, that's pretty fast. And yeah, generation is pretty good. Generation is pretty good. You have finally recommended on my for you page. Finally, I know you have chunks. Yeah, I do. I'm trying to make them. I'm trying to think about optimization for generation because I think this is going to be critical. Let's load chunks from memory first, probably. And yeah, I can't really. Well, I mean, I can open the engine if you want. Do you want to see what's happening? What I did? To load. Let's maybe not multi-thread it, but let's have it be for now. But let's have it be sequential and in cache. Okay, I can't watch stream because I'm in a call with my friend and I can't handle things at once. Okay, got it. That's fine. I can wait. So loading. Well, load from disk. Actually, load chunk from disk. Then we have generate chunk. Wait, this one doesn't exist. Yeah. Load from disk. I can remove this. Try load from disk. And generate chunk. Yeah. Load from disk generates chunk. And I'm on vacation in Greece. Oh, then I play Minecraft with him. So I won't be able to watch, but I have you on the background, muted for more viewers. So more frequently. Thank you. I appreciate. Thank you. So if it doesn't work, I'm basically going to say that it's going to, well, call generate chunk instead. Like if false poo and return, and else we call this with the new chunk. So if this is good, then we call this. If not, then this. Call back in case we can't load from disk. So now we want to generate. Haha. So we need the chunk generator and load chunk from disk. Okay. Wait. Good. Here we go. Is on disk. I guess I do want to know this. Is on disk. Let's say it's gonna be false by default. But I'm gonna have to implement it. To do implement. Then I generate. So to do implement. Loading. Wait, that's the chunk loader though. Wait a second. Wait a second. That's not really what I want. I mean the chunk visual loader, so that's not what I want. Oh no. Wait a second. Chunk visual loader. I mean, I guess it's kind of what I want, but it seems like very... Well, not about visuals at all. Well, actually, this is about visuals. Hiding neighbor. Kind of. So... I'm not sure about that. And I'm not sure whether collisions are going to do the same work or not. I mean, it might. Yeah, I shouldn't do that there. That should be something from somewhere else. Actually. Unchunk loaded. Wait. Actually, wait a second. I'm trying to think about things a little bit. So there should be some priority. Remove duplicates. Sort by priorities, let's say. By priority, kind of. To do. And then I want to request them from being loaded. So So chunk visual loader. Step. Request loading. And then I have all of this. But it's gonna be a different... I mean, maybe the inheritance is wrong in the first place. I think it might be wrong in the first place. I guess it depends. I think I need two different classes, chunk loaders, but the problem is that I don't know how to name them. I need one class that's going to take care of loading the chunk data, and I need one class that is going to be inherited from chunk visual loader, and the same for the collision loader, chunk collision loader. So it's kind of a problem. External chunk loader. Maybe it's going to be fine actually, because collisions are going to be a bit different too. So okay. Size. So many bytes. I don't have anything in there. That's crazy. That's almost 1 KO. Oh. It's because node is really big. What about object? It's like half? It's still half. It's actually still a lot. I'm kind of afraid. It's so much. How is it so much? Anyway. So I want to share the same loader. So for now, I'm just gonna remove this. Just a node. It's just going to be a node. So this is basically load chunks, chunk types. And this one is load chunk visual types by requesting. Oh, that's actually a good point. Types and request chunk loader to load additional chunks. Well, to load chunk types if required. Oh, that's actually... Oh, that's a good point. That's a good point. That's a good point. Because I'm checking the visuals. Um. Mm mm mm. Mm mm mm. Tab. So maybe that's not. Let's go to chunk loader. So I have all of this. And I have this. This is going to have a few functions from there. Like, step is kind of good. But, well, I mean, I guess I'm going to have a list of chunks to generate. Like requests. Request load, maybe. So, request load. Chunks. So I'm gonna have I get a lot of things like this. Requests load chunks with duplicates. Maybe. Should be good. Like, I guess I'm gonna have a list of chunks that I'm going to, like, I'm gonna have a state, and that's gonna make me do things faster. Maybe. I guess I do want to update the score of each chunk though. Every frame, maybe. So I'm not sure. Because right now, if I want to generate a new chunk, I have to load the previous one. Well, the one that is connected to it, which might be a bit of a problem. Is it? Not really. Actually, no. So anyways, to load, I'm gonna have this. I'm gonna go there. Chunk to generate. Let me still put this in here. Here we go. Good. Observers. Yeah. I mean, I'm gonna have observers probably, but yeah. We have this. We request. Is it good? No, it's not. We can request. We remove the duplicates. So to do remove duplicates. Maybe. Sort by priority. Then I do this to load from disk. I mean, I need some priority system though. I need some priority system. So I'm not sure about this. Because this is going to be like executed every frame, right? And maybe I just want to be careful about frames. So I'll be going here. I'll be putting that there. Is on disk to generate. Wait, it's there. To generate is there. Oh right, wrong. Wait, what? Undefined. Oh, no, it's not. Chunk loader. Let me just move some functions. So we have all of this to implement. When the chunk is loaded, I set them as neighbors. So it's kind of the same everywhere. Let me just have everything here. Chunk loader. Yeah, it should be fine. On chunk loaded. Wait, I don't have this one. Let's get it. Oop. Ah, here we go. On chunk loaded. Can I get the space? It's not incompatible error type. Got it. Got it. This is a chunk. Here we go. So compiler now, you know, space is undefined. I guess I'm gonna get the space then. No, by default. And dropping the const. Yeah, that makes sense. To load. And this one is gonna be to load from disk. Actually, wait. To generate to load from disk. Yeah. And this is basically going to loop over this, kind of. So I guess I'm just going to push, and every step I might pop back, but there should be some priority. Maybe I can have like some kind of free list and return request to load chunks. Yeah, I don't know about that. I'm not sure about that. To load, I can have the index. I can return the index. Yeah, I'm not sure about this. Incomplete type. This is fixed easily. Let's go there. Oop. Here we go, and find neighbor chunk. Wait, what? Oh, right. Maybe not. This is not implemented. Is neighbor chunk loaded? Okay. We do this to do implement. Oh wait, do I want this? Do I actually want this? It kind of depends on the space though. I mean, I guess that makes sense. I'm not sure about this, but yeah. So the chunk from disk. I generate. In the end, I'm gonna have kind of the same really. We do implement. I'm gonna call this to gen with the chunk. And yeah, there shouldn't be any issue generating. So when it's loaded, it does things. We're supposed to initialize the chunk too. I mean, that's probably going to be here. And what? Or maybe, actually it generates, wait. What was it? The virtual function find neighbor chunk. I'm not sure about this. Yeah, when am I even using this? Here, on chunk loaded. Wait, what? Wait, what? Why? I don't need this. Because I have the new chunk and I have the source. Like literally, I don't need this. So I have the new chunk. For oh, actually, never mind. I do. Okay, I understand now. Find neighbor chunk. Yeah, I'm not sure about this. I'm not sure about this. Maybe it should be like a function from the space or something. And what if it's null? If it's null, I guess it's just staying null. Like the neighbors are going to stay null. So if this is valid, then I do this, but if not, then I don't do anything. And this is probably... it's from the space. Because I want to remove a virtual from this class. And this sounds like it fits the thing. Like a function from a space. So chunk space. Maybe this. To implement. Find neighbor chunk. Yeah. Wait. Yeah, should be good. So we have the chunks, a list of chunks, and we can just get them. I actually have in cube chunk space, I have something for that. I have a map. So I should be able to do that directly. Yeah, that's actually good. And in cube chunk space. Override. I'm gonna do this. Override. and implement it. Okay. So now, how do I get the chunk? That's gonna be simple. I'm gonna get the coordinates. I guess it's a cube chunk. Cube chunk. Cube chunk equal cast 2. Chunk. Here we go. And it should be valid. I mean, it's like I have a macro for that in utilities. Do I have it here? I don't know. Anyway, let's say we have this. Then we have coordinates, chunk chords, and I can get neighbor chunk chords maybe. Oh. Wait. Let me think. Neighbor index. So it's really going to depend on like a neighbor index to offset to, yeah, like here. Never mind, in the cube chunk space maybe. I can have neighbor index to chord div. Let me check. To direction. To axis. No, because there's like +1 and -1. So that's going to be like a transform, right? From one coordinates to another. Maybe transform is actually better. Like move to neighbor maybe. Void move to neighbor. So we have vector 3i and chords. And I'm gonna return. Well, I guess maybe not a. What was it? Cube. Chunk. We have the coordinates. Cube chunk chords. Okay. So cube chunk chords. Move to neighbor. Oh. Like to neighbor maybe. We have the index. Neighbor index. And we can just sample from this. Like get neighbor offset. Gets. No, I think that's fine. We can just do chunk chords plus neighbor index in an array. That's going to be neighbor delta. Neighbor. Chunk chords delta. And get neighbor chunk chords. Should be good. It's in the space. So I can have. I guess it's just mostly gonna be static though, like constant. So vector 3i, this, we have how many? 1, 2, 3, 4, 5, 6. 6. And this is gonna be, the first one is going to be up, down, I'm not sure actually. And maybe I'm just going to reuse cube chunk. And we have the normals somewhere there. Maybe that's good. Maybe that's good enough. Do I actually have cube chunk? No, I don't. I can't like just do cube chunk this. I mean, it should still be fine. Let me just copy it. Oh, thanks. I actually don't have water right now. Let me get some. But I appreciate it a lot. Thank you a lot. Ooh, be right back. Okay, here I am. Actually, I checked the stream, so I sent a drink. Thanks. I'm probably going to go soon, but I actually say that every time, and every time I just stay here. So cube cards. I'm not sure about the coordinates really. I'm just gonna, well, I mean, I'm just gonna copy it for now, like this, and it should be fine for now. So then I sample from this and I return. And I have to create this. Okay, here we go. Actually, can I just remove this and do like this instead? Vector 3i to cube chunk cards. Yeah, never mind. Let's just do, well, the normal thing. I'll be watching this time unmuted for like 2 minutes. Okay, what a long time. Yeah, I mean, did you see where my game was? Like what I had? Because I guess I haven't opened the game for like a while. So I might show it to you really quick, but the time to open the engine, it might just take 2 minutes. So it's not going to compile. I have no hopes for that. I just want to run the latest build. Okay. So yeah, this is going to be... Never mind, like 3 minutes, okay? Look at this, then. Look at this. Okay, so basically I have my donut. I have a donut that's like generated. I have to improve the textures and like put some shadows and stuff because it's a bit hard to see, right? But it's there. I can put new blocks. I can I can build something if I want. Right. And I can destroy. I can go down. It's still a cube. I'm just seeing cubes. I actually have a bug there, I think. Because it should not be, I should not be able to destroy this. So bedrock can be destroyed. Okay, let's actually try this. I'm gonna set this to false. And it shouldn't be able to... Well, I shouldn't be able to destroy it. So let's see if it works or not. Destroy. And when I reach the bedrock, I can't destroy it. So I don't reach the singularity. That's like distorting everything, right? Like this thing. So this is good. And yeah, I just have this. Whoa, cool, thanks. And yeah, there's like, do you know why there's a singularity? I think you know. I don't remember, sorry, like people I explain it to, but well, I can't destroy it because I just, yeah, okay. I have to put a new block when I build. Let me go to, what was it? It's not the player. It's when I click. There's this cube chunk visual. I really have to move things a little because it's not really clean, but place cube. Here we go. It's like a bit hard-coded right now. Like I'm having this and I'm always going to put a specific block. But yeah, cube chunk space. Wait, cube chunk space. Wait, what? Wait, what? What is that? Oh, wait. Oh, right, I have to load here. To do load. I have to remember it. Cube chunk space. To do cube chunk space. When you have it finished, make it so you walk, not fly, and fly through walls. Yeah, that's why I'm... Well, I guess that's kind of part of... Well, that's my priority. My first priority is generating chunks, so I can see, like, infinitely... Like, so I can have an idea of, like, the performance cost. And, yeah, then I want to bring back collisions and, like, integrate them with gravity and stuff. So yeah. And yeah, like collisions are basically good. I basically have my main architecture, but I think some part of it broke. It's like not really optimized. It's just something that I have to enable here actually, like there. But it's also not updating right now. You could add if you press a key, you fly, and if you press the key again, you walk normally. I actually have like, I can switch cameras. Wait, is it working? Oh, wait, the collisions might actually be working again. So basically I can switch cameras, like as you can see, this is the camera that's on the ground, right? And this is the camera in the air. And this is the debug. I can't, right. I have to do this too. And this is the collider, the player collider. So I can go up and down. And we have the chunks that are colliding and stuff, right? And I can move, and it's basically what? Right, that's 2, never mind. Ah! Okay, so I can move. It's like the same camera, basically. Like I can rotate. This is like basically the same. It's like basically showing the collisions. Right? The only problem is that right now, the collision seems to be generated before, like this is generated. Like it doesn't take into account the cubes, it seems like. LADs, oh no. Sorry about that. But yeah, and I'm not updating it. I have to update my collisions. Wait, that's crazy. That looks crazy. It's like rotated. But yeah, I do need to do those things. But there's like the collider. Bro, another ad, bro. What? Oh no. I do have some problems when I spam. But for some reason it seems to be mostly fine. It's like, I was gonna say it's not random, but it's kind of random. That looks so weird. Look at this. Oh my god. It's so weird. Oh my god, I love it. Oh my god, I love it so much. I love it so much. But yeah, I have to update the collisions. Okay, are you back? So it's like in cube chunk space. Load. So invalid cube normal, try load chunk. Yeah, unimplemented. Okay, this is fine. This should be fine. Yeah, that makes sense. Let's just do this. Visual loader, so we have all of this. We basically step and we do things. I mean, this one should be kind of removed. Chunk loader. I actually moved it here. So what do I want? Unchunk loaded. I mean, I guess it's kind of fine. Then I just have the observers and find neighbor chunk. That's fine too. I don't need this. Well, I mean, I can use it, but never mind. Okay, should be good. Kind of. So then we have this loader. And I guess I want some kind of API that requests load chunks. So maybe one chunk at once is good enough. I want to set the priority of each chunk. And what? Let me think about it. Push back, na na na. Let's from this, and I do want to call back. I want to call back from this. So associate it to each chunk to generate. So let's say I have this. I'm gonna have callable unloaded. Maybe? Is it? Like loading. Wait. Visual loader. Let's check this. Neighbors. So basically that should be fine. To load pushback, I'm gonna have the chunk loader, like loader. This, I guess that means I can move this to the C++. I still don't have the observers, but that's fine. And at the end, I have the loader. So for each observer though, I'm not sure about this, but loader requests loads chunk. Maybe just one is enough. Yeah, just one is probably good. So just one. Like this. That way I don't need a vector. I don't need this allocation. Yeah, that's gonna be good. Good. Then I can just test this to load chunk 10. And then I guess, okay, I have the list. And then I guess every step I'm going to try to generate things based on the scores. So I'm gonna have unloaded, I'm gonna have a score, right? 0 is like big priority, I suppose. So yeah, let's just have a step. Like this. That's fine. Step to do multi-thread. Maybe I want to multi-thread this. So I guess I'm only going to generate one chunk at once right now. Because that seems like it's going to be a lot. So let's do maybe one of each. Well, that would be actually kind of bad. Maybe something like I equals 0, I is less than 5, plus I. And that way, like I have a limit. Like this. Is it? Oh, I. That's I. So I have a limit of chunks. NB. Like it's basically going to be NB generations per step. And NB this per step. Oh, is it? Okay, what if I want to generate 5 every time, but then I have the score, and I'm going to what? To get the minimum every time. So let's assume this is sorted. Actually, is it? Do I have sorted vector? Sorted vector. Tracy sorted, no. Hi, hello, unknown, how are you? Sort. Third party. Okay, so let's assume it's sorted. I'm good, how about you? I'm good, thanks. I'm just gonna do NB chunks per step. Just gonna do this. And yeah, have you... How was the game the last time you saw it? How was it? I never remember, I'm sorry. So let's say we have this. I guess I actually want to start from lowest to highest priority. That way I can puff back. That way it's like optimized and I don't need to remove, well, to reallocate the array. Well, not reallocate, but move, copy. You were struggling with the block placing. Okay, I actually finished that. Wait, the block placing, when was that? I don't remember like the order of things I did, but basically right now, I have this. I can place blocks. I can destroy them. I can go down, you know, the stuff. I can't destroy the bedrock, so I don't have this problem with the singularity anymore, right? I can't go down. It doesn't look like this, right? I actually have to curl those textures, probably. And aside from that, what? Let me think. But yeah, I guess that's, you know, already pretty good. We have some generation. Pretty basic, but yeah. And I was actually playing with something a bit earlier. Oh, I actually can't break those blocks anymore because it's the bedrock. But I can make a path like this, and it's just going to look curved. And that's like so funny to me. Just moving just curves it. Are you gonna make a survival mode? Yeah, I want it to be some kind of survival adventure game. Like Minecraft, like a bit of crafting, I guess. I don't really want the player to mine. So like mining would be pretty limited. And I guess I want the player to like explore dungeons and stuff. And planets and different things. Yeah, I guess it's mostly gonna be about dungeons. Like when I was a child, it was the same thing. I made like some dungeons in Minecraft to, like in a multiplayer server, and you had like some people just, you know, try to complete like the pyramid. The House of Traps. Some more like Minecraft dungeons. Let me just check again. Because Minecraft dungeon is like top down, isn't it? Yeah, it's top down. I mean, I haven't played it, so I can't really say. I guess the difference, well, a big difference is that it's going to be first player, right? Or maybe very close third player. But not like top down, not top down, for sure. And I want the battles to be different. And I mean, I don't know how Minecraft Dungeon is, but I basically hate experience systems. I hate experience systems. I'm probably gonna give instead, like when you complete a dungeon, for example, you might get like some artifact to help you, for example, like to teleport or something. Or like some energy, like a lot of energy that you can use for like your circuits and stuff, like to make vehicles, for example. I gotta go. See ya. Bye bye. See ya. Thanks for watching and being here. I appreciate. Oh yeah, maybe like some kind of artifact to increase the power of your sword. But yeah, a bit like very similarly to Minecraft. I don't want like Minecraft has an experience system, but they like use it for enchantment, right? I guess maybe something like that would be fine. But I don't want to just be able to level up forever and become just stronger and stronger, and yeah. Well, not by just like fighting, I guess, just by grinding. I don't want the player to grind. I want the player to explore and to test different things. So that's it. Yeah, I'm gonna close this. And then I'm gonna check this, if this is at back. And, oh, I actually have end. Wait, what is end? That's an iterator. Okay. So I get the score. If this is... So a low score, what does that mean to have a low score? I guess low score. Low score equal high priority. Like this. So then we have the score. And if this is less than to generate, and score, then I'm going to wait, never mind, that's not what I want. That's not what I want. I want to get the fifth. Well, the 5 chunks with the most priority. The good thing about Minecraft is you can do multiple different things like mining, crafting, and exploring. It's not like other games. Yeah, for sure. For sure. It's like a sandbox, right? And I guess I don't want my game to be a sandbox, but like you can mine, but like mining is not really that interesting by itself. Like it's interesting if you go into caves and, like fight monsters and find things like this. But like if you, well, that's what I want. Like I want the player to go in caves and do stuff, but I don't want the player to just break a block, wait a few seconds, break a block, wait a bit, break a block, and just repeat until you find the diamond you want, right? I don't really want that kind of thing. So I mean, that's like some that's some game design to think about. I would say in Minecraft, when you have to dig down and mine by yourself, the problem is, well, you don't know where to find a cave. So maybe I should have like some stuff indicating where caves are. Like, I mean, if I have like some big mountain, for example, with like a lot of holes, then it's like pretty obvious. But for example, I might also have entities that's like enemies, like monsters or like animals that only spawn near caves or that run to caves. That kind of stuff. I could have that. Maybe a map or a beacon to show where caves are. A map? I think that's going to be too complicated for me. A beacon is... I mean, it would like... it would... I think it would remove the adventure aspect of the thing, like the beacon. Kind of. The map is too complicated technically for me, maybe. Like, it's going to take too much time if I try to make it. Because everything is relative, right? Like, I'm not in a flat world. So that means I have, well, I'm on a donut, for example. So that means I need some projection to turn it into a flat map. And I could do that with a donut, because I already have my function stuff. But if I make like new geometries, then I won't be able to maintain the map. So yeah, that's the reason. seconds. But yeah, Beacon is kind of fine. I feel like this is kind of the thing I want, but I don't want like just to follow the map kind of thing. Like I want something that is inside the environment. Like it could be like some visual, like artifacts, you could say. Not artifacts, but some traces, some stuff on the ground, for example. Or it could be like some animal, some creature, something like that. I don't know, but yeah, I'm gonna have to think about it. Think about it. So, let me do. Okay, let me do 5. Yeah, I'm actually not sure about this because I want to generate the chunks with the lowest priority first, right? Oh wait, I'm gonna do that anyways. Yeah, but the order is still important between the two. So enemy chunk loads per step. I mean, I guess I'm going to need like a local vector or something. A new one. So top. The top is gonna be made out of wait a second. Pop, top chunks from disk, and top chunks to generate. I'm gonna have to cache this, but yeah, and basically here I'm going to push back to load from disk. That end, I guess. So like this. And I'm gonna pop this back. Pop back. Wait, I can't pop back. Wait, I can't remove it. Wait, that sucks. Count capacity. So there should be a pop back. Remove at. -1. Remove at unordered. Erase. Unordered. Reverse. What about a stack? Ordered insert. Oh. Oh. I like that. Well, there's an order, right? I mean, I can sort it basically. Well, I mean, that makes sense. Maybe a map. Wait, never mind. So local vector doesn't support anything. Go to local vector. I might want to make pull requests about it, because it feels like pretty obvious functions that we don't have in Godot for some reason. So Godot local vector. Wait. What am I doing? What am I doing? Like else? Else I'm going to do this. Tap chunks to generate. I'm gonna push back. Yeah, pop back. Local vector. No, that's not what I want. Add back, pop back, and remove back to local vector. Please. Please. Why is it not merged? Triggers via pull request. It's not there. Wait, what? Why is it not? Wait, that's an action. Wait. In there. Local vector back access. I want this so much. One commit ahead. And that many behind. So why is it? Please pop back. Pop back. It's copying the value. Wait, there's a copy. I guess it's not really a copy. Yeah, never mind, it's not a copy. Is it? No, it is a copy. Yeah, never mind, that's fine. Yeah, that's fine. Back. Let me go there. Actually, no. Contributor. Okay, there. Draft. Please. I did. Enhancement. Alternative. This has back access to local vectors, so it can be efficiently used as a stack. The current prevalent class for stack-like containers is list, which is very inefficient. In draft until it's actually needed. I added an access method back, which returns the reference to Nana. Yeah, I really want this. 4.x milestone. How many months ago it was? Was it? January. Please. Yeah, I'm gonna... Actually, I don't know about the rules. I don't want to just spam. But actually, it's saying until it's actually needed. I mean, I do need it. I need it. No! Yeah, I'm gonna send a comment on this. It's compiling and stuff. Review required. Let me just check how they actually comment. Looks good to me. Yeah, let's just send something. Maybe not hey. Either force. Um, Thanks for the fix. Well, not the fix, but the... Wait, it's closed? Why is it closed? What? What should it return? Oh. Too rusty? Yeah. This star. Split the local vector change and list change to keep PR small and easy to review. This one adds back and pop back methods to local vector. Well, it does. It's just capable as a stack. It will be used to replace list-based stack in following PR. Useful functions. To return the value instead of destructing it. SCD vector pop back, return void. Yeah. Yeah, same. Thus harmonizing local vector with list suffice as a reason to add the functions. It just closed. I have some ongoing changes that use this. We'll submit this along with those. Wait, it was in March 2025. And then, yeah, you have this. Okay. Yeah, I'm not sure about the pop back. Remove at. Yeah, I'm just not sure about returning, about doing a copy. I'm using local vector a lot. And it's really painful not being able to call back. Back. I hope this will be merged soon. And I guess the only difference is with remove back. Oh, remove back is actually pop back. Oh, I guess that's fine then. Oh, and that's a move. Yeah, that's fine. I guess remove back is fine. Here we go. I spent way too long looking at this review, this pull request. Anyway, so then we have to generate. Yeah, that sucks a little. So I have all of this with like 5, and that means afterwards I'm going to loop through both lists So generates chunk. Well, actually, just this. I'm just gonna do this. I'm not sure if this is really worth it, but yeah, I can try this. That's basically going to be the amount of chunks I want to take care of before restarting. Well, yeah. Okay, 5. Let's have this here. I can even I can make this static, but I guess I can also add it to my class and clear it every time. Here we go. So the memory is gonna stay allocated. It's like a bit of an optimization, you could say. So we do all of this, generate, load from disk, So then I have to implement this. I guess I'm gonna change things a little bit here. I can remove the array. This is good. Instead, I can have request load, which is gonna be this. Has no member. Okay. Let me go to chunk loader. So we have a few observers. Maybe I'm gonna remove this. But for now, it's gonna be in protected. And request. Oh yeah, without the S. Okay, so we request the load. We might have some score. And we might also have a callback on loaded. And we're going to assign it to what? I guess I can bind some variables, but it's gonna be on chunk loaded. On chunk loaded. And I have to verify that this is not being loaded currently. I mean, I guess it's just gonna go inside. And I'm just gonna see it in here. So it should be good. Remove duplicate. Plus... not remove duplicate, but... yeah, to do... Don't add those that are already being loaded. Well, I mean, I can do that right now. Can I just... oh, wait, push back. What about sorted? I can sort. But what about insert? Ordered insert. Oh. Let's do this. And yeah, this is gonna be good. Probably. So we can insert it, sort it like this. Actually, if this is less. Oh, there's no comparison operator though. Sort custom. Ah! Ordered insert. Ah! Wait, that's a T? It's not even taking a reference? Why is that? That's so weird. Wait, why is that? That's so weird. Yeah, give me my templated insert. And it's not even... Oh no! Ah! There's not even a binary search. There's no binary search. Oh, this is so bad. Maybe I need find custom. Yeah. I'm not sure about this. Okay, anyways. So I have to load from disk and to generate. So for... Well, I can just find, like contains, not just find. If I find this, 64, so that's the index. And I have a from, okay. I have this. Index, like, let's do index equal this. Actually, what is it if it's like minus 1? Okay, never mind. So if do I really want that? I mean, am I going to have a lot of chunks or not? Maybe I want like some kind of hash map or hash set. Maybe not actually. Chunk to generate. Yeah, that's actually going to be a bit tricky. Because I don't know the coordinates there. So I can't do a comparison. And I'm going to have to do that somewhere. Whether it's in generate chunk. Actually, generate chunk is maybe fine. Yeah. Or load chunk from this. This one is not fine because we need an ID. Oh, but it's just an ID. I mean, I guess I can get the ID. Like, it could be a string name, not an integer. And if it's a string name, then I mean it's just good. Is it? No, it's not. Maybe it is. Maybe it's good actually. Yeah. Okay. Okay, so yeah, maybe I want IDs for every chunk. I do want those. I've been wanting them for forever. Forever and ever. Can a string name be an array of... just an array of things, of characters? Well, an array of bytes, because if it is, then I can have my integers directly as binaries, which would be nice. Yeah, that would be nice. So maybe something like string name, get ID, compute ID, like ID, chunk ID. Chunk ID. I don't know. Because I can have an ID pretty easily with like Euclidean geometry. But what about non-Euclidean geometry? It's gonna have to do with transformations anyways, right? 1, 1. Right. So in the end, I'm still gonna have like some unique things. For example, some unique transformation from the origin. So that should be fine. ID. So let's say we have an ID. Well, wrong one. Wait, what? What is that? Yeah. Unchunk loaded. Let's say. Does not match. Okay. Oh, that's yeah, you have to do the collabel, new collabel coder. Oh, it's just collabel, right? Like this. Maybe not. Mem, that's mem. C++. Collabel MP. And we have this. Right, and this. With the type. And here we go. But yeah, it looks like it's not really optimized. Like there's a lot of things I don't wanna... Like Godot, I don't really like Godot actually right now. Like the C++ side of it. It feels like not optimized at all. And I'm kind of worried about this. I mean, the good thing is that for some reason it's like very fast. Like, well, it's working on very bad computers. But yeah, like arrays and stuff is just, I don't know. Like, I guess there's JavaScript too. It feels like, I don't know, never mind. So we have this, and then we have the ID. So the ID is gonna be something. Maybe I have to compute it from the space. Get chunk ID. Nope. Something like this. And like build chunk ID. And this is going to be where we're going to send the chunk. We have space. Should I bulk generate the IDs? And have a std vector. Is it worth the... Probably not. So yeah, let's go to space. We have a bunch of things. We are gonna have build chunk ID, which is a string name from a chunk, and this is gonna be virtual pure. So this is gonna go down here. And I'm going to do the same as for the other ones. I'm going to implement it. Find neighbor chunk. Wait, I haven't even finished implementing this function. Wait, what? Find neighbor chunk. So we have this. Wait, what? Why do I have this here? It's like already defined in the parent, right? It's actually not. Neighbor index. But it's... That's so weird. Am I even using this? I'm just find neighbor chunk. I'm just accessing the neighbors though. So what's the problem with this? The amount. I don't have a list of neighbors. Oh, that's the space. Wait. That's the space. Yeah, why is it like this? Cube chunk, get neighbor chunks. Should be good enough, right? Find neighbor chunk. Neighbor index. Yeah, that's kind of crazy. Cube chunk space. Okay, let's just go in the other places. Like this is just chunk get neighbor chunks and neighbor index. Kind of. That should be it. I can optimize it, but optimize it, yeah. So this one is gonna be a nope. Wait, actually. Oh, right. It's because of this. It's because we're not neighbors already. Right. I understand. Okay. So chunk space, whatever. Cube. Where was it? I removed it. Here? No, not here. Cube chunk space. Cube chunk. Here? No. Interesting. Interesting. Override. And it doesn't have a cube chunk space. CPP. Okay, now it's good. So let's just go there. Boom. So I guess I can... It was add, it was transform, it was move. No. I know I made a function for this just before. Const, wait, that was around here. Const indices. Oh, that's in the space though. Yeah, that was in the space. Get neighbor chunk cards. So I can do this with chunk, well, cube chunk cards, and then we have the neighbor index. So then we have the neighbor chunk cards. Const. Oh, it has to be const. Okay. So then we have neighbor cards. And from this we can do a find. And the default is like PTR, get PTR, chunk index. I'm not sure about this. Wait, chunk index, right. So this, it has the index. And if this is true, then we just return the chunks, well, the right chunk, the chunks index. And if it's not true, then we return get, maybe? We return no. And it's like a dereference. And this one is, well, it should be a const, right? Yeah, should be good. Okay, should be good. So now we found it, I guess. I'm actually not sure about this. Like, basically, I feel like I should have a map linking the f name instead. The ID. But I'm not sure because there would be like some cost, some conversion cost. So yeah. Maybe it would just be the binary of the vector3. It would be nice if I could have like a union. Yeah, a union would actually be nice. So when I build the ID, I'm just going to return, wait, cube chunk. I guess in this case, it's gonna be chunk cards. Well, let's get this. Or maybe, okay, let's just ensure that this is not null. Same up there. And this is going to be cube chunk cards X. Then we're going to have Y. Let me actually check inside what this is. Data. And we have equal, string, the operator, equal, and other constructors. So those ones should be nice. Static, what is static? I guess it's like to copy the thing, is it? Static count. Increment. So we allocate hash. Yeah, what is even the hash? Is this string hash? Avoid negative values on platforms where car is signed. Avoid negative values. Okay. Yeah. And then it's doing things. Okay. So I'm probably just going to try this. It should be. Let me think. Let me think a little. If I have bytes, is it going to copy things? I mean, it takes from a const car, right? So technically it should be good. By default it's false. So let's just have this. 2 bytes. I don't know about the length though. That means I'm going to have to allocate. Oh no. Oh no, not an allocation. I don't want that. But I mean, I guess overall, actually I already know the amount of bytes. So this is good. The amount of bytes is the size of an integer. 32 times 3, right? Because it's this. I guess it's vector 3i type, something like this. Left, wait. Why is it even? Wait, where are the variables? There. Chords. Oh, I like this. So in 32, got it. Good. Times 3 plus 1, because we want the final character. Actually, what about... Oh, that's not going to be good, is it? Because... What if one of the byte is just 0? If one of the bytes is just 0, that means we can't put it inside. That means we can't have a string name. Oh, that's kind of bad. I mean... Maybe I'm just going to... The string? No. The string builder. Do I have a string builder? I don't. So id equal this. What? id plus equal, like, can I do this? In 32 new. What about this? Oh, I can actually do this. Wait, I can actually do this. Wait. Vector 3i. That's like the conversion. String. Wait, not this. Vector 3i string. Operator string. Okay, so we have this. We have this, and what it is, what is it? Integer to string. No, okay. So, I mean, let's have this. I guess. It's like not the best, but, you know. Like something. We can just return. So we have an ID, I guess. The thing is, it's not free. That's my problem. If it was free, it would be good, but I feel like I'm going to have to generate them every frame. For every new chunk, I mean. So I'm not really sure about this. Or like every time I move to another chunk, actually. Yeah, I guess it's not that bad. Well, kind of. Yeah, I don't like it at all. That's fine. That's not. We're gonna see. So anyway, we have the build ID. We have the ID. So then I can just try to find from the ID. So like custom. No. There's no custom search. That sucks. What about this? For example. Find back. Oh, there's no back. Either. Okay. Let me actually just look at the Godot pull requests. I just wanna look what they're saying about arrays. C++. Let me go to Godot engine. Godot pull requests, and I want to check array. Oh. Improve performance. Implement GPU mappable buffers. Mappable buffers. Wait. A separate transfer queue. This means transfer workers cannot overlap their work with the previous frame and can only execute after rendering has finished. As a result, the cost is paid by the current frame. Buffers are created as both GPU visible and CPU visible on human devices. And data is copied directly to the map's memory pointer. This allows us to skip transfer workers entirely, while also overlapping the operation with the previous frame. Oh. So wait, what's that? Using the following script, which creates a lot of array meshes every frame in a GPU-bound scene to exaggerate the problem. So we resize like every frame. Whoa. But yeah, basically it's kind of optimizing things without me having to do anything. So it seems kind of good. Textures could also benefit from this, but Vulkan only supports it through the VKX host image copy extension, which doesn't seem widely supported, so I haven't mapped it yet. It's pretty easy on D3, D20, DirectX in comparison. I also need to check Metal. Godot Sponza with max settings. May not see any performance difference since I figure Apple devices have proper async transfer queues. I just want to check this. I'm just kind of curious, actually. If it's mappable, then it's doing things. pool. Then you have the pool. Wait, so there's a DirectX implementation. I haven't seen it yet. I mean, it's in drivers. Okay. Add initialization of typed arrays dictionaries. What? What the fuck? Using a ternary operator. Oh, okay. I get it. Maybe. Uh-oh. Yeah, I'm losing time. So I'm trying to find this. Or maybe not, actually. I'm just going to loop right now. Or maybe hash a hash map. I'm going to have string name. And that's it. Maybe with this. So hash map. Maybe I want a pointer because it seems like I'm going to have a lot of copies and stuff. But anyways, I'm gonna push, or I'm gonna do chunkgen.id equal this. Yeah, it's not going to be good. String name to the chunk, maybe? Well, chunk and index. Yeah, I'm not sure about this. I mean, if it was in a single vector, then I could have indices there instead. But yeah. Okay. Let's have this. Maybe a hash set actually, since I don't need this. Hash set. Index hash map. I'll be set instead of this only if the following conditions are met. You need to keep an iterator or const pointer in your intent. To add or remove elements in the meantime. Iteration order does matter. So RB is like, it's a tree, right? It's red, black, such. So yeah, this is the one I want, hash set. And it's just going to be chunks. Wow. Whipped chunks. Chunk IDs. So add, push, or just problems, public, so erase, add is empty. Do reserve, insert. Here we go. We have this. Perfect. And then basically we can just find. Actually, is insert good? It always seems to be good. There's like no try insert. So if I find it's returning the end, well. If this equal this. Then I return. Don't add those already loaded. Then I want to sort by priority. But yeah, basically then I just add, and then I do things, right? So I say I have to load by priority, but that should be it. And then I should load by, well, load from disk. And then I should generate it. So I guess the chunk loader is going to have a reference to the generator. Cube chunk. Yeah, this one has nothing, right? Yeah, it does have nothing. So let's go here. Okay, I guess I'm going to have the... Actually, I have nothing here, except a generate function. That's like not even implemented. So generate chunk, generate all chunks. I mean, I guess I want a specific chunk. Where am I calling this though? Wait. GD. And then we have this. Then we have here. Wait, we have here. Generate all chunks. Okay, this one is working. And this one... The space, chunk, and chunk cards. I mean, technically I already have the space though. But yeah. So I need the coordinates, that's the problem. Actually, I just realized, but I have... Right now, I have like one variable in every class, but maybe I should have functions instead, like virtual functions. Should I? No, probably not. I'm actually not sure. Anyway, so generation. Right, but it's a bit difficult. It's a chunk loader. So maybe it's about the space. Maybe it's about space. So does the space have the loader? Loader. Well, it doesn't right now. But it could have a generator. I guess the space should have both a loader and a generator. A few problems. Build chunk ID, no, okay. So this one is going to be... is going to have chunk loader. And it's also going to have the generator. Chunk generator. Like here. Okay, and it should be good. It should be fine. It should be good. Nothing better than this. So now I can access space. I can access the generator, maybe not. Well, let's say that this is public. So I can access the generator. I guess I have to include it. And yeah, it needs to generate from this chunk to generate. Like chunk to load, I guess. Good question. Generator. Just let's just include this. Modules. Voxel. Generation. Chunk generator. And yeah, actually this is like a very good way to... Oh. Yeah. Chunk to generate. And chunk to load. Yeah, maybe that's like two different things. Chunk to load. So this one is gonna have like an ID, maybe. And the one to generate is just going to be generated from and this. Maybe. Generation data. Well, generation data, yeah. Or is it? Do I really need this? Do I really need this? What about in the chunk? Chunk loader. I mean, it's here actually. So yeah, I have a list of IDs, but I don't know if they're like unique. I have to find a way to check if like it's unique or not. I mean, I could have variants actually. Wait, what about a variant? Oh wait, that's crazy. Wait. Godot. Oh, variant comparison fast. And what? For trivial types, maybe. And is it fast to create one? Fast. Can I have it in a hash set? Oh! Yeah, that's it, some cost. Small POD like types. Very cheap. Variant has an inline storage area. Attack union, so for primitive types it doesn't need to allocate memory. Copied inline, also cheap. And maybe a bit more. Because of reference counting. Stores an object pointer, cheap. Oh, okay. I didn't know that. So this is actually kind of good. Also very fast. Compares the type enum, compares the underlying value, and just do the thing. Row int comparison is small. Wait, this is actually so good. Complex types. Yeah, I mean, of course, yeah. Hashing variant. I mean, this is perfect. Let's actually try this. A performance comparison. And now something like all of this. Voxel data. Yeah, I mean, of course not. Of course not. Of course, I'm not going to have that as like a voxel. Okay. Yeah, vector-free I chunk. Yeah, I mean, I'm not sure about that. Variant add type checks. Larger object size. Indirect dispatch. Memory cost. Yeah, much larger than an integer. Memory overhead. I mean, I don't have a lot of because there's a buffer, right? But like vector-free I is already pretty big, so it might be fine. It might be alright. Let me just think a bit more. I mean, string name is really attractive to me, but like variants might be a bit faster to create. So I'm not sure. Let's keep it like this for now. So gen, okay. Score. Wait, what? Chunk to generate, chunk to load. Right. Everything is just this now. Chunk to gen. Invalid. Let's have this in my visual here. I'm gonna just change this, and I'm gonna have the generation data like this. So now this should be somewhere. I feel like there's some problem with like dependencies, but I mean, why not? But I know why. Okay, never mind. Cube, chunk generator, let's go to the parent. Let's go there. So this is going to be my data. I'm going to actually just replace what I had because I don't want dependencies between the two of them. So I'm just gonna have this, and I'm gonna remove what I just added in here. So we have all of this. Then we have the... Wait, how much? 5 hours. That's fine. Already 5 AM. Generates chunk. Okay. So let's go to here. Maybe not. No. Here. Generate chunk. There. So we get to the generator, and we try to generate something, but I don't know what actually. I don't know what. Oh yes, the data. Yeah, never mind. Yeah. So let's go chunk generator. The generate is just bad, I guess, right now. So instead, it's going to be this virtual function. And generate is going to have some chunk to generate. Yeah, this. Good. So now we go in chunk cube chunk generator. We overload, and we should be able to find back our space, our chunk, and the coordinates too. So it should be pretty good. Generate, yeah. Generates chunk. I guess we have to generate chunk. Let's just keep it like this for now. Yeah, this is pretty good. Generate all chunks. No. Just gonna do this. Yeah, so I still have generate there. Here we go. Default chunk size, add chunk. Essentiate. Yeah, let's just do. So we basically want to call generates chunk. Like, I guess it's gonna be generate cube chunk in this case. Generates cube chunk. Here we go. Here we go. And this one too, I guess. This is going to be generate chunk. So it's a bit more, so we know about what we're talking about. There. Generate chunk. And now I can get the space. Oh, wait. Oh, right. Chunk that. Actually, it's like from a space though, right? Well, I mean, it doesn't really matter. Generated from. We get the space, I guess. We get the. Oh, I have to create it. Yeah, I have to create it. So cube chunk space. Let's put some checks just to be sure. Here we go. Then I'm just going to have the same. Ooh. Wait a second. So I can do this. I can maybe optimize things a little with this. And it doesn't really matter, I think. But yeah. And I can cast. I mean, it's already done. This is done too. Chunk space. Wait. Origin chunk. That's actually what I want to do. Where is it? I mean, it's a chunk, basically. I just want a new chunk. Wow. Okay, I have two of them. Chunk data. So I'm gonna get the space from this. Space. I check, I instantiate, everything's good. So now I can put the space, I can have the chunk, and I can have the coordinates that are going to be chunk data. Oh yeah. So I mean we have this. I can have cards, get neighbor chunk cards. So we have the current coordinates, and it has the neighbor index. Cards. Neighbor cards equal this. Here we go, here we go, here we go. So now we can generate. And when it's generated, then I mean it's just generated, right? Generates cube chunk, so then I assign. I mean, I guess I register the chunk to the space, so that should be good. I just need to do move to callback, maybe to without a callback. Generate cube chunk. Yeah, I mean, basically, I should have like some callbacks and stuff, and I should maybe at the end of this function. I'm not sure. Generate chunk. I'm not sure about all of this. I have to make sure that thread-wise everything is fine. Because when I access the chunk, this is safe. But what about the space? Space, default chunk size, NV cubes. I mean, this should be fine. This should be constant. Chunk cost, this is fine. And I guess this is it. Maybe I can just get this ahead of time, actually. Chunk space. Oh no, wait, that's not good. It's just space. Okay. Gets amount of neighbors, I guess. By default is true. Move to louder callback. Register. Yeah, the register is not going to be there. NB neighbor chunks. Okay, I can get this ahead of time. I can get this, I can get this, I can get this. Okay, should be good. Should be good, I can parallelize this. Good, good, good. And yeah, I guess that's gonna be it. So I'm probably gonna stop for now because I'm forgetting what I have to do. But I guess we're gonna continue next time maybe. So to do connect, well, link generator and louder to chunk space in editor. Try to step the louder, and that should, well, and also have the generator actually it's gonna be good. Support async with callbacks, but maybe just sync for now. So now from the loader I generate the chunk, and I mean I guess that's gonna be it. And when I do this, I can just load C++, I can generate the chunk. I have chunk to generate. Like there. To gen. Oh. No, this is good. Generated from. Wait, why do I have? This is like the old data. Oh, I have two to gen. It's to load. Generated from. Neighbor index. Boom. Now I can try to generate it. So to do async version. So it's supposed to return the new chunk. Return value type does not match. Yep. And I'm just gonna warn. I'm just gonna warn. It's not initialized. It's not registered. Well, it is initialized, but it's not registered yet. Set chunk space. Maybe I want to set. Well, never mind. Chunkers to check index. Yeah, it should be good. So not added, not registered to the space yet. So we have this. We have the parent. Good, good, good. Then we return type. Yeah, I just changed it though. Oh, it's not. No, it is forward declared. So let's go there. Let's go there. Let's go somewhere. You and me. Lauda. So we have this. We have the new chunk. And we want to call this, well, just chunk actually. Chunk equal this. I mean, I guess it's like pretty straightforward then. New chunk. I can remove. And we do this. There. Okay, we generate. And we call this directly right now. Which is good enough. I actually don't want to do this. I actually want to move this somewhere else. Like generate all chunks. This is gonna go there. With the space being here. And move to loader callback, yeah. And this might actually be private. I don't know, maybe not. Generate chunk. Let's go in the loader. And I'm just gonna do this. Maybe? Wait. Actually, never mind. It's gonna be, well, unchunk loaded. I mean, when it's loaded, I guess I need to do this. Chunk, space, register chunk, or not. Wait. Oh. Chunk space. The register function has to be, well, cube chunk space. It has to be virtual. So this one is gonna override. And the parent one is going to add it. I might want some basic implementation though. Like the set chunk space. Maybe not this. Wait, actually I want to do this before. And then I add child. So let's do this. Wait. Chunk space. Wait. This. Here. Cube chunk. Uh-oh. It's just gonna be a chunk. And I'm going to move this there. So then we have chunk, register, chunk at one point. Or like chunk space actually. Chunk space, register chunk. Yeah. This with this. Okay, now it should be good. Now it should be fine. We register, we have the loader. We register first. And we do a lot of things. So on chunk loaded, this is called directly. So that means if I have an async version, I can very easily, put a callback and stuff. And what about the callback? Let me think about this. I don't need unloaded yet, do I? Wait, I actually need it from the visual thing. Probably. yeah. So link generator and then we have update creates new chunk space visual spawn new chunk space visual from chunk when chunk loader finished its thing, right? Yay! And only update this when the player changes chunks. So add callback for that. We're just gonna add a callback for that. I mean that's actually not gonna be true because we want some priority thing. We want to be able to set priorities. So that's not really true. There's like a lot wrong with this. Makes the player able to change, make chunk visual loader able to change priorities in the chunk loader depending on camera direction, etc. Something like this. But I'm not sure how I'll be able to do that. I could have a reference towards vectors. No. No, maybe not. I don't know. But we are progressing, I guess. It's a progress, and it should be like pretty good when it's finished, when it's done. So the base loader is pretty good. The generator is now kind of compatible, which is great. And yeah, I mean, yeah. Generator is finished. loader is kind of getting close to finished, but it needs some more APIs. Like the API is kind of bad. So yeah. Chunk visual loader. The real problem is here. I have the unloaded, and I can actually wait. So it's gonna generate. And when it's loaded, I'm actually just gonna do to gen unloaded. Wait. To load. This that's unloaded. I can actually just do this call. So I'm gonna call this. Do I need the priority generated from? Not really, right? So I guess I just have like a new thing. Okay, this is actually pretty good. And now I have a chunk. I guess it's just a chunk. On chunk loaded. And we should have, I mean, call step. Chunk visual loader. Notes to myself. So when it's loaded, I can basically do a mem new chunk visual. Well, maybe not actually. Oh, it actually depends on the space. So space. Chunk space. Yeah, this one is a bit different. Chunk space visual. Am I using... I am using those. Chunk space visual. Let's have this. Okay, we are going to initialize this right now. And add observers. So then we have this, we have a few problems here. That's why we are going to include two modules, voxel, no, voxel, rendering, chunks, cube chunk visual. No. Spaces, chunk space visual. And we're just gonna get the space. We're gonna do the same there. Like, let's just actually, well, let's get it, I guess. Okay, here we go. And then we have the visual space loader, so I can instantiate maybe something, like instantiate chunk visual. And I can instantiate it from a chunk, basically. And it should be like pretty good. It should be pretty good. Right now, in what? Yeah, in chunk space visual, I actually, like there, I have update chunks visibility, which is kind of bad. But this is basically the class as the function I'm spawning chunks from. So instead, I will be able to, I mean, I can actually do that right now. I actually just want to continue again and again, but then it's like 5 AM. So yeah, remove this chunk space visual, remove this, and add Torus, no, visual loader, and add this. Okay, should be good. Anyways, Should be good. Should be good. Should be good. Oh, just finish it. Okay. Let's go for it. And yeah, that's gonna be it. That was a lot. We haven't finished. I wanted to finish that today, but I guess I couldn't. Because I guess architecture-wise, it's very tricky. And it was like very... Like, you can think about different concepts with the same name. And it's just gonna confuse you. Well, it's just gonna be confusing. That's what happened with the chunk loader for me. But I guess it was good in the end. Maybe I still want a parent for chunk visual loader, but yeah. Yeah, should be good. So yeah, thank you a lot, people, and see you next time. Boo.